Good afternoon, friends, and welcome to this international conference on vermifiltration for wastewater treatment, progress and prospects in India. My name is David Tompkins. I'm head of knowledge exchange and innovation for a UK-based wastewater consultancy called ECOIND. I will say a few words of welcome and then cover some of the housekeeping aspects, mostly of relevance to the speakers today. I will also formally thank our speakers and panel members at the end of the event, but would like to start by thanking most sincerely Rohini and PG Ganapathy at the CDD Society in Bangalore for helping us to create this event on behalf of the INNOQUA project consortium. Thank you. Just briefly about myself, ECOIND is one of the 20 project partners who have delivered the INNOQUA project over the past 4.5 years. My professional interests relate to the use of treated sewage sludges and similar materials in agriculture, both from safety and sustainability perspectives, but also from market and consumer perspectives. My role in INNOQUA is to support the communication activities, and you are to raise awareness of the INNOQUA project, and particularly the Lumberjack or Vermifilter that's been developed as part of that project, but perhaps more importantly, to increase awareness of the very extensive and robust vermifiltration expert community in India from commercial and research perspectives. Primarily, please treat this event as a forum for an exchange of ideas and experiences on vermifiltration. So in terms of housekeeping, my functions are to keep us to time and to ask questions if there are insufficient questions in the Q&A box. Each speaker has a 15-minute slot, and we have left it to them to decide whether to speak for the full 15 minutes or to leave time for questions. Although I do have short biographies for the speakers, I would ask that they introduce themselves, please, at the beginning of their presentations. I would urge speakers to please respect one another's time and not to overrun. Please mute your mics and turn off your video if you're not presenting. I will pop back up on screen when there's 2 minutes still to run in each slot, and I will make myself alert. You'll know I'm there, and I will wave this in front of you. As a last resort, after 15 minutes, I may cut the speakers off. So forgive me if I need to do that. That's not desirable, but we do need to try and keep to time as far as possible. As delegates, welcome again, and please type your questions in the Q&A box. If speakers don't have time to answer them during their sessions, or they're not raised during the concluding panel discussion, then the event team will collate them and circulate responses by email after the event. You should already have received a Zoom link for the networking meeting that will start immediately after the close of today's formal proceedings, but we will share this link again later in the Q&A box, so don't feel that you're going to miss out. There will be an opportunity to interact with panelists and ourselves after the event. So that's all I have to say, and without further ado, it gives me great pleasure to welcome today's first speaker, PG Ganapathy from the CDD Society in Bangalore. Over to you, PG.
Hi, David. Thank you so much for the introduction, and I hope I'm audible. Let me also share my screen and just let me know if that is also okay. Then I will. So is my audio quality okay, and is the screen sharing working for all of you?
Perfect. Thank you. Yes.
Okay. Great. So once again, very good morning to all of you from Europe. Good afternoon to those who have joined from India and from other parts of the world. We've had an excellent participation in terms of number of people who have joined. Just shows the level of topical interest, and glad to see that. As David said, at CDD Society, we were fortunate to be able to be part of this EU-funded INNOQUA program, where we as CDD were able to offer our services and as a host of the demo site and supported the project. It helped us learn from the project, as well as happy to see how we can take this forward in India. So we're looking forward to that also. So before I go further, for those who may not be aware of CDD, a very brief word. We are a not-for-profit established in 2005, based out of Bangalore. We have about 50 plus engineers and sciences people working with us. We are largely a technical organization with trying to bring holistic kind of approaches, but coming from a significant technical lens. We were set up originally with the support of German government grant through BORDA, and later on had funders like Bill and Melinda Gates Foundation join us. And today we have a good mix of funders, and we do a lot of work for the governments in India also. In terms of what we do, our history, CDD stands for Consortium for DWAT's Dissemination Society. And we started with wastewater, decentralized wastewater. DWAT stands for Decentralized Wastewater Treatment, and we started with that in 2005. But moved on from there into the mid 2015 thereabouts into fecal sludge management, and then today into water body rejuvenation and to some extent in solid waste management. And our perspective is to try and bring an integrated urban water management perspective. And our specialization is to offer it through nature-based solutions for water and sanitation. And our nature of services are like technical kind of services, capacity building for the sector, applied research and development, and that's where the whole INNOQUA initiative fits in, and knowledge management dissemination, like this webinar, for example. And now, before I start talking about the subject, I'll switch to giving a brief context for vermifiltration. So, I mean, all of us in the sector are aware that mid-80s, 90s, it was largely when wastewater sector and wastewater treatment and looking at wastewater as a serious challenge was taking off in India. We were largely looking to the West and trying to copy the centralized approaches to wastewater treatment. While that had its place, I think in about 2 to 3 decades of making that attempt, all of us realized that we probably needed alternate approaches. And that's when CDD sort of pioneered the idea of decentralized wastewater management approaches. But looking at a city context, like if you have traditionally the dense central areas of the city, which can be called the core areas of the city, which are typically where a lot of sewer systems have been laid. Then you have the peri-urban kind of areas of the city, and then you have small campuses, self-contained in themselves, like gated communities and institutions and so on. Now, what we feel as CDD over the years, while there was a focus on centralized wastewater treatment to start with, over time, it is given way to a mix of solutions approach. Today, there is a strong recognition that India needs actually a mix of solutions approach, and every kind of system, whether it's centralized, decentralized, small networks, or on-site systems supported by fecal sludge management, all of these have their place, not just in an intermediate sense, but probably in a longer term sense also, as part of an overall strategy in a mix of solutions approach. And then, I mean, as part of this, decentralized wastewater systems are sort of gaining ground. And that's because they do offer significant advantages. The biggest of them all is, let's say, the cost advantage, although in terms of treatment process, the centralized systems on a per cubic meter basis might look cheaper in some sense on a per cubic meter basis compared to decentralized systems. The real cost of centralized systems is actually the heavy cost of laying sewer networks. And it's not just cost, it's also the time that it takes to actually lay a centralized sewer network. And so from both time and cost angle, developing countries like India are increasingly realizing that perhaps decentralized approaches are faster and overall, in a system cost sense, cheaper. And this also enhances once you start taking the overall life cycle cost of OPEX and so on. So decentralized systems do offer many advantages. A couple of additional points to highlight are with water scarcity becoming predominant, the whole idea of reusing treated wastewater is an important theme today. And in that sense, decentralized systems offer far higher, far higher possibilities of local reuse. Whereas if you have to take a centralized system and reuse that water, you have to lay an alternate network to bring the treated wastewater, which makes it even more expensive. And hence, many of the reuse projects based on very large scale treatment plants don't seem to have worked in India. And decentralized treatment definitely offers that possibility. plus, of course, greater participation of the beneficiaries community, whoever owns that system, lower risk in the sense that these are small systems, so even if it fails, it's just a local failure of a small system. So cost effectiveness, possibility of reuse, lower risk, huge number of advantages that decentralized systems offer. And therefore, because of that, they have been gaining ground. The Central Public Health Engineering Organization, formally recognized, and CDD played a pretty important role in this whole process, to include it in the lexicon somewhere around 2013, and even said that that should be seen as a system of choice also, wherever possible. And then in more recently, I think there's been an elaborate effort by CPHO to print or to produce a publication offering guidance on on-site and off-site sewage management practices, covering all technologies. And similarly, the National Green Tribunal is also proposed. So overall, we do see a huge offtake, and so this is just our estimate from different sources, perhaps from about not more than 2,000 decentralized wastewater treatment systems with small networks, about 2,000 systems. Perhaps today we think there might be around 20,000 systems in the country. And there was some study done by the EVAC team called the Forest Study, and this is what they estimated to be the number of decentralized systems in this country. So clearly, decentralized systems are here to stay, and they are gaining ground. And if you look at the history of what has happened since, say, about 2005 onwards, the first wave of decentralization was through compressing or packaging conventional large-scale technologies into smaller packaged plants. So we had the activated sludge process, MBBR, SBRs, and all other related processes that were built for a sub 1 MLD scale, 100 KLD, 50 KLD, and those kind of capacities. However, they did suffer a bit because they were somewhat complex in their process design and required some skilled labor to operate them. So there was some of the small scale systems, people could not spend money employing qualified people to run these systems, and hence there were teething troubles when these were installed in resident welfare associations or small communities. And people were cutting corners by turning off the blower to save cost and so on, and systems were not delivering. So there was initially did face some criticism that decentralized wastewater systems are not working. However, that's when nature-based solutions like DWATs and a few other systems slowly started becoming important and relevant in the scheme of things, and started gaining popularity. More and more people started asking for it. These are some of the popular names listed here, and there are many more, and those can be seen as variations of each of this technology. The soil biotechnology by Vision Healthcare, we have Chandrasekhar, who's going to be part of the panel discussion. Their organization has promoted SBT, as it is called popularly, where they have vertical flow filters, bioreactors that, and in some of them, they also use worms. So that's one kind of system which has a settlement followed by a bioreactor. The phyto-ridge system by NERI, National Environmental Engineering Research Institute, is another very popular system. And our own CDD's DWAT system and its variants are also quite popular, which is predominantly anaerobic, followed by a post-secondary module, which is more aerobic. Now, these offer lower O&M. They don't need blowers and pumps. Typically, pumps may be used at times when the gradients and hydraulic lifts are not in favor. But generally, for process, they don't need much energy. And the anaerobic system, DWATs especially, and many of these other nature-based systems also produce less sludge. So the whole problem of sludge management is much more reduced in these kind of nature-based solutions, decentralized solutions, which are more nature-based like these. However, it's not that they don't have their challenges. They compared to some of the mechanical systems which have stronger controls, you can say that the level of process control maybe is a little less in these decentralized systems because you're leaving it more for nature to do the job. Initially, at least, there was higher capex, but over the years, all of these systems have tried to optimize their cost. And today, in my view, between the decentralized electromechanical systems and the nature-based systems, it is almost comparable, the initial capex. However, majority of them require a little larger footprint, but there again, there has been innovations happening, and some systems have started competing even from an area requirement perspective with other kinds of electromechanical systems. And then, of course, our standards regime has also been very dynamic and has been becoming stringent. Today's standards require about 10 BOD to be for release into water bodies or streams. So achieving a kind of 10 BOD is not easy even in conventional systems, and surely gets challenging in nature-based systems. And therefore, you're having to look at innovative tertiary treatment approaches, which some of them could be a bit electromechanical in nature, to really achieve those kind of standards, whether it's meant for reuse, you need those standards for reuse, or if you need those standards for even discharge. There is a need to sort of probably bolt on some additional modules at a tertiary treatment stage to make these nature-based systems also deliver higher standards and output quality. And these systems have, over the years, last 10 years particularly, has been really a flourishing period where many projects have got implemented, and across 400 plus systems that have been implemented in India today by CDD alone, and taking into account what others have done in NIRI and SBT and variants of this, perhaps there'll be more than 1,000 systems today. And a whole lot of optimization has happened on CapEx, OpEx, area requirements, and even in terms of achieving better output quality. So they are gaining currency in spite of their slight challenges that they offer. The other effort has been towards new innovations in nature-based solutions. There are systems that are based on algae that is being experimented with. We have Vermifiltration, which is what we're going to talk about today. And there have been some experiments in India, effective microorganisms, and combinations of this mix and match kind of approaches and so on. So what we find is that this is a very happening space right now. And in this happening space, today's topic and conversation is going to be about vermifiltration. So the question really, which a lot of the other panelists who are going to speak after me will address, is what is vermifiltration? What is it all about? And what kind of research is happening? What has been the initial experience of commercializing and applying it on the field? So we have a mix of nice, varied kind of speakers who are going to present their cases. And then we're going to have a rich panel discussion at the end of it where we hope to try and address some of the open-ended questions. With that, David, I'm 2 minutes early and I pass on to you to take it from here. And I'm really looking forward and want to take this opportunity again to welcome all of you to this conference. And I really wish that we have a great conversation and discussion going ahead. Thank you. Over to you, David.
PG, thank you so much indeed for that great introduction. Before you leave us, I have one immediate question, which you may be able to answer, and it's a question of compliance. So a question might be, for example, if you leave the treatment of wastewater to householders or smaller communities instead of centralized municipalities or larger organizations, is there a risk that the treatment efficiency will not be as it is required? And just to note, we have no such requirement in the UK. If I, as a householder, I could have a small system and there would be no requirement for me to have any training or to guarantee compliance. I just wondered if you had any thoughts on this.
Yeah, so today in India also, when you have on-site systems like the septic tank and soak pit and so on, there are no norms governing the discharge from that. So individual households, yes, I don't think they're still covered, but even group housing, communities which are even 20 households and more, and it varies from state to state, but in a state like Karnataka and city like Bangalore, anything about 20 units requires to set up a community level treatment system, and they are subject to standards. And today, the unfortunate part is the standards that are applicable to the 50 MLD or 100 MLD scale plant is the same as what applies to a 10 cubic meters per day or a 50 cubic meters per day plant. And we are hoping that in India, we would have a more nuanced regulatory regime that distinguishes between small scale systems, medium scale, large scale, household scale, and so on, and also distinguish between nature-based and the other kinds of systems in order to sort of encourage greater adoption of these systems. But the problem of saying yes at the household level, the challenge of ensuring that those standards are met are an issue. But I think governments can be a little pragmatic there and find ways of setting standards in such a manner that the environmental damages are minimized. Yes. Thank you.
Perfect. Thank you very much indeed for that answer. Again, conscious of time, so I will now hand over to my INNOQUA colleague, Costel to deliver the next presentation. So over to you, Costel.
Thank you very much, David. Ganapathy, can you please unshare your screen? I hope it's visible now. Good afternoon, everybody. Okay, thank you. I'm Costel Bumbac. I'm a research scientist within the Environmental Technology and Technology Transfer Department of ECOIND, Romania, and demonstration manager within the INNOQUA project. ECOIND is a national research and development organization in Romania dedicated to environmental research and services, providing services in the field of pollution control, environmental monitoring, impact assessment, ecotoxicity studies, or air, water, wastewater, and soil treatment technologies. The INNOQUA project, which is a European funded project under the Horizon 2020 program, research program. The project is managed by SOSOA from France, from Nobatec in F4, which is a private research and development organization focused to drive innovation from ideas to market-ready solutions in the field of energy efficiency and environmental quality of buildings and neighborhoods. The focus of the project has been to develop, optimize, and demonstrate in real environmental conditions the reliability of a modular, cost-effective, and natural-based solution for decentralized wastewater treatment suitable for both rural and urban environments all over the world. To say it short, we focused on the desiderate of sanitation for all, trying to answer with a viable solution to those most in need of such sanitation systems. The project brought together the experience of 20 partners with complementary knowledge and backgrounds, starting with the technology providers, meaning Nobatec as provider for the Lumberfiltration technology, University of Girona as provider of Daphnia filtration technologies, Heliopur technologies, and later on, with the help of ECOIND and Nobatec, have been responsible for the development of biosolar purification, while Berson UV have brought the UV light disinfection module to the system. We also have knowledge providers to advance the understanding of the systems and enhance system performances. We have system integrators to prove and fine-tune the technologies at pilot scale level, and field demonstrators to prove long-term reliability of the system in real environmental conditions. The consortium has also dedicated partners for intellectual property rights identification, exploitation strategy development, and market building. The team of the project has gathered people from institutes, universities, small and medium-sized enterprises, large industrial partners, or even NGOs from Europe and across the world, including Tanzania, India, Ecuador. The project had an integrated approach trying to reach all aspects required for bringing the developed sanitation solution to market, including market studies, social acceptance assessment, legal requirements applicable in all targeted markets, requirements, life cycle analysis and life cycle cost analysis, and of course, special focus on communication and networking. The INNOQUA system is modular by design. The main idea is to add different modules representing complementary technologies according to treatment requirements and reuse perspectives, thus trying to meet the discharge limits of most countries, making the system versatile and adaptable to local requirements of both rural and urban environments. Lumberfiltration, also known as vermifiltration, relies on the power of earthworms. This is an engineered trickling filter to treat wastewater. the module being responsible for primary and secondary treatment, TSS and organic load removal, but also nitrification and partial denitrification have been identified with consistency in our demo sites. Daphnia filtration, a technology used as a polishing step or tertiary treatment, is based on the power of Daphnia, which are water fleas, to further remove fine suspended solids, including bacteria, while the biofilm in the interior baffles of the reactor are responsible for nutrient removal to a certain extent. The biosoil purification is a polishing treatment step based on a thin layer cascade photobioreactor, responsible for advanced nutrient removal through the activity of microalgae biofilm, while the UV light disinfection module is based on a LED UV source in a quartz sleeve reactor and is designed for a specific disinfection application when reuse of the water is envisaged. The Lumberjack, the focus of our conference today, is a reactor-based technology operated as a trickling filter. The reactor is filled with successive layers of materials with different functions. From bottom to top, we have river pebbles in two size ranges as draining support, followed by wood chips or coconut husk chips, or even wood shavings we have tried in some of the demo sites, as active layer for biofilm, and of course, home of the earthworm population. The earthworms we have used were indigenous species. Mostly used were Icenia fetida and Icenia andrei. Based on the research data gathered during prototyping phase of the INNOQUA project, the system has been installed in more than 1 year ago in 11 demo sites in 10 countries: France, Ireland, Romania, Scotland, Turkey, Ecuador, Peru, India, and Tanzania, to demonstrate in real environmental and operational conditions the long-term viability of a modular and locally sustainable treatment solution. Locally sourced also, as the only common thing were the tanks, which were adapted to the technologies themselves. The demo sites, now operational for more than 1 year, have been treating wastewater, biodegradable wastewater of different origins, municipal from domestic dwellings, office buildings, touristic residence, educational institution, dairy farm, or even aquaculture sludge through lambri-composting. The challenge was to see the adaptability of the INNOQUA system in treating different wastewater quality and to assess treatment performances, capabilities, maintenance requirements. The influent wastewater quality varied widely from tens of thousands to thousands of milligrams per liter of TSS, from 300 to 8,000 milligrams per liter of organic low POD, and from 30 to 180 milligrams per liter of nitrogen ammonium. So from typical European-like wastewater to very high loaded organic wastewater specific to low flush systems or agricultural industry. Different integrations of the INNOQUA technologies have been chosen depending on influent type and quality, treatment target, discharge and or reuse option, considering the climatic conditions and space availability. In all demo sites, the main treatment is being performed within the Lambri filter, which is the core technology of the INNOQUA system, while as polishing step, we have tried either Daphnia filtration or BSP, or even both in parallel lines for comparative reasons. Where reuse of the treated effluent was desired, an UV disinfection step was added for safety reasons. The pilot site in Ireland has been operated for more than 450 days in real environmental conditions at Tuam Research Facility, National University of Ireland in Galway. The specific testing conditions included temperatures of 5 to 20 degrees Celsius for the influent wastewater, while ambient temperatures were from -5 to 26 degrees. The Lumberfilter had an active layer of 1 meter in height and was operated at a specific hydraulic loading rate of approximately 0.5 cubic meters per square meter per day. This site was used as a pilot site as well to assess loading rate influence, unexpected shutdown impact, different influent delivery mechanisms. The removal performances registered were about 80% for total suspended solid and COD, and approximately 90% for BOD5 and nitrogen removal. No maintenance were required except the topping up of the wood chip layer in 1 year. The second demo site I will present today is still in Ireland. Tested the suitability of Lumberfiltration in treating agricultural wastewater, specifically dairy parlure from a cow farm. The purpose was to reduce the total nitrogen load of the wastewater, allowing the farmers to spread more of this wastewater on the field, since total nitrogen load per hectare is the limiting factor in applying this type of agricultural wastewater on the field in Ireland. The treatment performances in terms of nitrogen load removal were more than satisfactory, in average 68%, meaning that the farmer would be allowed to spread on the fields at least a double amount of this wastewater. In Italy, we have installed a compact INNOQUA system. The system is installed in the basement of a residential house at by the sea, treating the wastewater generated by 4 people. The configuration installed is Lumberfiltration as main treatment and UV light disinfection as a requirement to meet the microbial load limits of local discharge regulation into the sea. The treatment performances have been consistent for 1.5 years already, meeting at most times the discharge limits. The configuration of Lumberfiltration plus Daphnia filtration is installed in France, Romania, and Scotland. The system in France, for example, serves an office building, treating the wastewater generated on the premises of Novatec headquarters. As you can see, the influent is of relative high strength since it gathers mostly the wastewater from toilets. Still, the Lumberfilter proved efficient, treating with high performances, approximately 80% of the organic load and nitrogen ammonium, and removal performances of above 85% for BOD and PSS. The systems in Romania and Scotland have been installed as demo sites for extreme weather conditions, as the environmental temperatures ranges from -15 to 30 degrees. And as a protective measure, the systems have been installed either in a technical room or have been insulated. The systems we have in India and in Peru are evaluating comparatively the performances of the Lumberfilter in combination with Daphnia filtration or biosolar purification as polishing steps. The details of such a complete integrated system and its performances will be unveiled by the demo site manager in India, Mrs. Tatjana Schellenberg, in the following presentation. The observations we had so far in terms of performance and maintenance include the need. The Lumberfilter is a robust technology performing with well at different loading rates, and even after long shutdown periods, as we unwillingly have experienced due to the COVID crisis in several sites. The system performances recovered fast once the system was fed again. As maintenance, we observed the need of occasional racking of the top surface layer and the need of wood chip addition to maintain the height of the active layer. You have here the list of the contact details of all demo sites. The information is also available on the project website. Thank you for your attention. If there are any questions, I will be happy to answer them either now or in the chat box.
Fantastic. Thank you very much indeed, Costel. Just there are some questions that have come through the team. It's one of the limitations of this platform that as delegates, as our audience members, please use the Q&A box to raise your questions during the presentations, and then behind the scenes and myself, we're keeping an eye on the chat in the Q&A box, and we'll pick questions out then to present to the panelists. As panelists ourselves, we cannot put questions in those boxes, so we're using WhatsApp to communicate with one another. And there are a couple of questions from Chandrasekhar Costel. And the firstly, can you comment on the flow rate for the Italian demo site?
The flow rate, the hydraulic flow rate of the Italian demo site was 450 liters maximum per square meter and per day. But in average, it worked with almost 300 liters per square meter per day.
Great. Thank you. And a question that I suspect Tatjana will also cover is, does the air and water temperature influence the performance of, particularly of the Lumberfilter?
There is a certain influence on the performances, and it works better when the influence is between 15 to 25, and a certain reduction in performances is observed outside this temperature interval.
Thank you. And there are two questions in the chat box. Firstly, can you say anything about the footprint required for a 10 or 100,000 litre per day Vermifilter plant? So a question of sizing.
So our typical 10 people equivalent system has a footprint of 3.5 square meter. So this means for a typical European load of wastewater, 1.5 cubic meter in hydraulic load, and the associated loading rates of pollutants.
Great, thank you. And the final question that we have time for is, do these separate INNOQUA units have defined treatment standards, or is the standard applied to the combination of units as a whole?
Sorry, I haven't received well the question.
Oh, for sure. So the question is, are there defined treatment standards for each of the units, or is the standard for the combination of the units during the project?
And when you mean standard treatment?
For discharge purposes or reuse?
Oh, discharge limits are very, very different from one country to another. For example, in Ecuador, hardly any treatment is required because they are so relaxed in terms of discharge limits. But usually, for most countries, the Lumberfiltration alone would meet the discharge limit. But for some specific countries, polishing steps are required, even for decentralized systems.
Great, that's very clear. Thanks very much indeed, Costel. At that point, we'll move on. So thanks again, Costel, and I'll move now to Tatjana, who will give us an overview of the Indian demo site. So over to you, Tatjana.
Hello, Christoph, can you turn on the video, please? Hello, can you hear me?
I can hear you, but it doesn't seem I have my...
Your volume is a little low, Tatjana.
Okay, I cannot start my video because it was blocked. Can you kindly unlock? Okay, many thanks to you, David, and also Costel for the introduction to INNOQUA, and of course also a big thank you to all the attendees today who are joining us for this conference. So my name is Tatjana Schellenberg, and we're going to start the presentation. So I am a research engineer and the responsible demonstration site manager at the INNOQUA demo site in India, based in the mega city of Bangalore. And today we would like to present to you our findings of the experiences which we gained now over the course of more than a year in operating the site. BORDA is responsible for the INNOQUA operation here in India with the great support of CDD Society. So, but before we go more into the details, I would like to invite you for a short field visit of our site in form of a movie, which we have compiled to give you a little bit a better overview on the site and on what we are doing.
Tatjana, we aren't seeing your video.
You have to share your screen.
Yeah, you have to share screen and pick the video, Tatjana.
Oh, this doesn't work. Okay, one moment. So, pardon. Is it working now?
Yeah.
Yeah, it's beginning to load.
I think the connection is very poor, Tatjana.
Yeah.
So to Christoph, are you able to share the video from your end, please, if possible? And then we'll come back to Tatjana for the remainder of the presentation.
Yeah. I can. So. I think we lost Tatjana. So
would you like me to share her? Would you like me to share her presentation, Christoph, and then hopefully she'll be able to join without video and then just talk us through it?
Yes, she has to. Right here, she has to check in again. Okay.
So I will. So we will pause for one moment, and there are some questions in the chat box, and I'm aware that Costel is addressing those as he can. Costel, if you'd like to open your mic and answer them live, then you're very welcome to do that.
Okay, thank you, Dave. So there was a question on what's the largest Lumberjack capacity we have installed so far. Within the project, we have demonstration sites at maximum 3.5 square meter.
Hallo? Tati? Ja.
Hallo.
Irgendwie rausgeflogen. Und
das Video hat irgendwie nicht funktioniert anscheinend.
Ja, das habe ich ja gezeigt, das Video. Das ist gelaufen. Jetzt versuchen wir dich hier wieder als Diskussionsteilnehmer reinzukriegen. Ja, du bist schon wieder Diskussionsteilnehmer. Okay, dann können wir das dem Dings sagen, ne? Okay.
Okay, Costel hat übernommen.
Ja, okay.
So I was saying that within the project, we have installed our largest lumber filter of 3.5 square meters suitable for 10 people equivalent. But we have a project partner, Lumberjack Association, which has a system installed for a small community, rural community, of and takes over the flow of at least 500 people equivalent. And the system has been running for 16 years now, with little to no maintenance. And no sludge has been generated or evacuated so far from that system.
Great, many thanks, Costel. I believe that Tatjana is now back with us. Tatjana, I have your presentation on screen. If you'd like, I can just move through the slides. If you'd like, just tell me when you need me to move.
Okay. My dearest apologies for that. The Wi-Fi was not as stable for the movie to proceed, it seems. So thanks to Costel for taking over. So the Lumberfilter, or as the focus is now of the conference into the Vermifiltration. Here in my going to focus to the Lumberfilter under INNOQUA. The installed system size, which we have in India, is a 10 population equivalent system. David? Okay, the next Lumberfilter characteristics. This is what I saw last. I'm not sure how far Costel covered the presentation.
Tatjana, I haven't covered your presentation. I have answered some of the questions in the Q&A box.
Oh, so the presentation is already covered in total?
No, he has not done your presentation, Tatjana. You need to start, if necessary, from the beginning. Costel was just answering some questions from his presentation.
Oh, okay, good. I understand. There was a delay where I saw the presentation moving. So, okay, thank you very much. So in this slide, On the demonstration site characteristics, I want to give you an overview of the Indian demonstration site and the given installation. So the size which we have in India is a 10 population equivalent system, which was determined in prior pilot results, and we have 9 households connected in a water scarce and marginalized community setting, meaning that we have a very low water consumption as there is no direct water supply and there is no connection to a sewage network with a waste. So basically what this means is because there is a high risk of health and the discharges happen in the open field. So the source is composed poor flush toilets and a washing room in the households. One characteristic which I want to point out for this demonstration is that we want to address the topic of fecal sludge management, and in the Indian demo site we are dosing the wastewater in an unsettled manner via a pump and different frequency intervals for the different modules. We started our analysis last year in July 2019 and still are carrying on as of now with October 2020. Please, the next slide. Thank you, David. So in order to give you an understanding on the wastewater which we feed in India to the system, is that due to the low water consumption which we have in the community and of course the dosing in an unsettled manner, we have a very high strength wastewater in the Indian demo site. And here I want to highlight some of the few parameters which we tested, starting with total suspended solids, which we observed can be as high as 4 grams per liter and on an average 2,200 milligrams per liter. This continues with a BOD of maximum 2,000 and an average of 1.2 grams per liter. A COD again with up to 4,200 milligrams per liter received and an average of 2.2 milligrams per liter, 2.2 grams per liter. Ammonia of an average of 104 milligrams per liter. And as we are in India, we are one of the sites which are tested for the conditions of the global south. We have, of course, also raised ambient temperature, but also raised receive wastewater temperature of up to 30 degrees, 38 degrees Celsius. So I conclude that in India, we are analyzing our systems under extreme conditions with parameters which exceed typical but also critical ranges for worm species, Daphnia species, and due to the high loads which we have in India, also the recommended operation for the UV disinfection if we consider suspended solids. So the next slide. Yes, with a focus on vermifiltration, I give you here an overview on the Lumberjack under the INNOQUA project. So we tested the system in the range of a hydraulic load up to 1.6 or 1.7 cubic per day. And it is a vertical flow filter, which is comprised of, which has different filling materials. In India, we use coconut chips. To further address also sustainability, as it is commonly found waste material and is accessible. And furthermore, we use gravel. When it comes to worm species, we have chosen 3 different types of worms, which is the Eisenia fetida as the most common, but furthermore a local species which is called Perionyx excavatus, and Oidrilla species cover a broader range of optimum conditions or optimum characteristics for them when it comes to temperature ranges or humidity ranges, and this of course secures the operation in wider environmental conditions. So the dosing is arranged over a splash plate. This serves to ensure an even distribution over the whole surface area of the Lumberfilter, but also to avoid clogging issues. We feed the Lumberfilter in intervals of 1 hour to 2 hours. The next slide, please. Yeah. So finally, I want to show you also the performance results which we get for the Lumberfilter, but also for the overall system performance for INNOQUA and the 2 different streams. And as you can see, highlighted in red in the upper table, is that the efficiency which we get for the Lumberfilter, despite the changed conditions which we face, are quite high. So in average, we see that we have removal of total suspended solids of 88%. For BOD, it's 93%, 83% for COD, and 85% for ammonia. And one further point which I want to point out here, that the standard deviation is quite low, which means that throughout the course, very stable for the end, which you can see here with a minimum, as example for us, of 6, where we carried out on maintenance and have digged up the filter in order to put more chips layers to fill up the coconut chip layer. So when we look now at the performance results for the 2 different streams of the INNOQUA system, we can see that also here. Okay, sorry, my can you go 1 slide back? Okay. That in average for the stream of Lumberfiltration, Daphnia filtration, we achieved performance ranges all higher than 90% and close to 100%, with 98 for TSS, BOD 99%, COD 96, and of 94. For the stream of Lumberfiltration biosolar purification, we can also see performance ranges for BOD, COD, and ammonium above 90%, with a slight decrease for total suspended solids of 18%, where we have observed 6 months of operation, the biomass is increasing, and thus we get values which are going into the negative ranges, and which is for us a learning to include this operation and maintenance step to achieve even higher values for the future. So now the next slide. Yes, my last slide, where I want to thank you for your attention. And okay, now the presentation disappeared.
Many thanks, Tatjana. You were slightly lagging your voice through the presentation, but hopefully our audience were able to follow the presentation and particularly the results. There are a number of questions in the Q&A, but I'm aware now we are running late, inevitably because of the minor technical issues. I will ask the question though about the worms. So were the high temperatures that you were seeing in your Lumberfilter, did they impact on the earthworms?
Yeah, this is a good question and very interesting. We were expecting that we will see a difference, especially during the hot months in India. But in the evaluation, we have, as you could see also in the performance of the Lumberfilter, we don't have major drops in the performance. So it's a very stable operation throughout the whole investigation period, and we could not relate it to the temperature.
Perfect. Thank you for that answer. There are a number of other questions in the chat box, so if you're able to address those offline, that would be fantastic. But for the benefit of our delegates, I will move on through the agenda. So thank you again for your presentation, Tatjana.
Thank you very much.
So it gives me great pleasure now to hand the baton over to Professor Sinha, And so, Professor, the floor is yours.
Share screen. So, put it back. No, cannot really start my video. Okay, so the video is on and screen share.
Yeah.
Okay.
Now it works. We can hear you and we see your screen.
Yes, hello.
Yeah, we can hear you and we see your screen.
I can see your screen, written Zoom on that.
Oh, that's good.
Oh, okay. Yes. My first slide is there.
Yep, so it will move. You just use this cursor and then it will move.
Can I speak now?
Please go ahead, sir.
Okay. Now, about this vermifiltration technology, I developed this technology over here in Australia at Griffith University in 2005. The world is passing through a severe water crisis these days. UNEP has also warned that within 25 years, half of the world population could face hardship in finding enough water for drinking, sanitation, and food production. Under the circumstances, only when the wastewater of the society is cleaned enough, to be reused, for particularly in agriculture, which uses 75% fresh water of the earth, and for other non-potable purposes in industries and everywhere, sanitation and all that, then only the civilization will have a safe future on earth. The earthworms are really the unheralded soldiers of mankind, as Sir Charles Darwin told, centuries ago. They work as a, soldiers for mankind. They detoxify and disinfect the wastewater. All kinds of wastewater, municipal as well as industrial, even toxic wastewater we have treated over here. And they have completely removed all the, impurities and made the water clean and even nutritive for the farmers, one of my students work in India on the vermifiltered sewage on the rice crops. It gave a very high good productivity. The seed count in a single branch was 371 as compared to just 176 grown on the normal water. So that is what we are hoping from the seed. This, you can see the rice grown on the normal water and the other one grown on the vermifiltered sewage, the difference between the two. Can you see that?
Yes, indeed, sir.
Okay. So the vermifiltration system is quite simple. Just the beds contains some stones, pebbles, sawdust, and all that. And see, I have given that how simple is the vermifilter bed. And the whole technology is self-promoted, self-regulated, self-improved, self-enhanced, low energy, zero waste technology, easy to construct and operate and maintain. Yeah. See how the earthworms act for. Earthworms' body work as a biofilter. They disinfect, detoxify the wastewater and make it nutritive by enzymatic degradation and also by biodegradation. gut of the earthworms is a microbial factory. It has a lot of good bacteria in them. Earthworms bioaccumulate even the toxic chemicals, including the heavy metals from the wastewater, making them harmless by combining with some special proteins. They also kill all the pathogens, bacteria, fungus, protozoa, nematodes in the wastewater by the antipathogenic celumic fluid which they have, that is a blessing of nature that for the earthworms. Earthworms were the only organism to survive in the Seveso chemical disaster in 1976 in Italy. In 3 kilometer radius, nothing survived, no organism except for the earthworms. So they are really blessed for that. Now, in the treatment, the BOD is reduced by 95%, COD by 85%, TSS by 95%, TDS of small because it is also useful for agriculture, turbidity by 95%. The fecal coliforms are completely removed, over 99%. And the dissolved oxygen value in the sewage water is increased significantly. That becomes good for irrigation. Worms also devour on all the solids wastewater and prevent the formation of sludge. Number and population is important factor. About 8 to 10,000 moles per square meter of the vermifiltration bed is required, and which occurs very quickly because the worms multiply very rapidly, and this achieves this number. Okay, good. So, and the next is I talk about the economic and environmental benefits and advantages as compared to all other system of wastewater treatment, which is being followed. There is no sludge formation at all, which is a biohazard, and that requires a special landfill for disposal, secured landfill at a very, very high cost. Here there is no sludge formation because the earthworms eat the solids from the wastewater. And even if there is some formation of sludge, the earthworms degrade them and convert them into vermicompost. There is no use of chemicals for disinfection of water. Earthworms does the job. There is no foul odor. 75% less electricity is required. Much less construction materials are also required. There is low emission of greenhouse gases, which is very important today, which is inducing global warming and climate change. All vermifiltration or other sewage treatment plants, they emit powerful greenhouse gases like nitrous oxide and methane, which are 300 times more powerful than carbon dioxide. There is no low emission and very low emission that I worked at Griffith University also. And that is one of the best, character of this vermifiltration technology. It can be decentralized anywhere, avoiding long distance piping and all that. And another good effect is that huge earthworm biomass is generated in every vermifilter plant. So that can be used in other vermifilter plants, to install other vermifilter plants. And also the earthworms are now using for composting of solid waste to produce vermicompost, which is a good for farmer, more than 40, that is also my area of work, more than 40% growth and productivity has been achieved in the crops using the earthworm vermicompost, eradicating the agrochemicals, which has become curse in disguise for human beings, for the farmers. Thousands of farmers are dying because of the pesticide poisoning and all that, and because of the chemical pesticides in the food itself. So that is one of the greatest benefit, that huge earthworm biomass is generated, which is used for more vermifiltration of sewage water and vermicomposting of solid waste to produce vermicompost. And these days now, in many countries, it had been started to produce vermimedicines from the earthworm biomass, which is anti-cancerous, because earthworms are the only organism on this earth in which cancer could not be induced. And therefore, people have started producing those vermimedicine from the earthworms, and very soon, probably it will come. That is a really a good thing, And the last thing is that the investment and the operating cost is also much less, by 70% than all other conventional sewage treatment plants. So these are some of the very, very economic and environmental benefits and advantages of vermifiltration technology. Earthworms are really proving to be, a blessing for the human being, as said by Sir Charles Darwin. Now, this Transchem Agritech in India, whom I gave my technology, which I developed over here, has really done a very good. They have commercialized my vermifiltration technology, and with a very significant scientific improvement. Dr. Mandar Prabhu, he's a technical manager. He has really brought a good pride for me. I'm really feel indebted to Transchem Agritech, its CEO, Mr. Atul Shroff, and all that. More than 100 commercial vermifilter plants are now working in India, under their guidance. They are treating sewage and wastewater from several industries. And, they were honored by Government of India in 2017 and with a award of Waste Management Excellence Award. One can see me in one of their vermifilter plant on the YouTube also, just going by wastewater treatment by earthworms, Dr. Rajiv Sinha. See, one of the vermifilter plant that is from the outside. The storage tank is in this side. This is the inner view of the vermifilter site. The sprinkler is used for just spreading the sewage on the vermifilter bed, and the water is being used as a garden at the vermifilter site. And see, before treatment, what was the color, what was the situation of sewage, and after treatment. Transchem is treating all these wastewater, all the various kind of industrial wastewater, chemical, toxic wastewater, also coal washery, milk dairy, vineyard, food processing industries, freeze, meat, woolen and textile industries, color and dye industries, the toxic wastewater, and several types of municipal wastewater. That all on the slide, the audience can see. These are the resource generated. This is the report by Transchem. How there are 200 KLD plant or 1000 KLD plant in rupees. What are the economic benefits anyone can get, by using this technology? Thank you. I highly acknowledge Sir Atul Shroff, the CEO of this is for you, and Dr. Mandar Prabhu also for commercializing my technology. They have brought great pride for me in the whole world. I'm known in world today because of this. And there are some few people, Professor Nirmal Kumar Mishra, Professor Radha Kale, and Professor Maria Soto. They gave me, they were my teachers, Professor Nirmal Kumar Sinha and all that. They gave me knowledge about the earthworms quite back when I was a student. And Dr. Radha Kale also from her publications. And Professor Maria Sato, she was one of the pioneer worker on vermifiltration technology in Chile. But I did not know. When I published my paper in 2008 in Australia, then she gave me congratulated me, writing me email, Anyway, so that is all about this vermifiltration technology that is going to really resolve the whole problem of water crisis which the civilization is facing now. And this has got to be promoted all over the world. Earthworms are really, truly speaking, they are what Sir Charles Darwin said, that they are unheralded soldiers of mankind and friends of farmers. And we have proved it scientifically that yes, he was 100% correct about that. Okay. Thank you very much for giving me this time. Usually I take more time for speaking in more details about the earthworms. And if anyone has any question, please write me on the email, which Rohini Pradeep has. Okay, and I'll be very happy to give all the other and details on anything, whatever questions they have, they can ask me on the email. Okay.
Professor,
thank you, Dr. David Tompkins.
Thank you. Thank you. Thank you very much indeed for that great presentation. We're very fortunate to have a presentation later today from Transchem, so we will hear more about
I also feel very proud. Yeah. Well,
yeah, perfect. So yeah, thank you.
We will all the governments install these vermifilter plants everywhere in the world. And in India, at least I want every state to follow that, what Maharashtra and Gujarat has done, and in southern Indian states, which I have seen. Okay, thank you so much.
You're very welcome. We have
that whenever you want, you ask any question on vermifiltration or whole vermiculture technology, vermicomposting, vermifiltration, vermi remediation, vermi agro production, whatever. Okay, thank you very much.
You're very welcome. Thank you. So we do have some questions in the box. I will ask just one if you have time. And the question is, when the earthworms accumulate toxins, what happens when those earthworms die? So do the other earthworms consume those toxins again, or do they leach from the system?
You know, few species of earthworms, that is especially Sinha fetida, eugenis, and Peronix excavatus, which was shown earlier also. One of them is known as tiger worm, Sinha fetida, which survived the Seveso-chemical disaster in Italy also in 1976. You know, earthworms are really blessed. They bioaccumulate toxic chemicals, and they have a protein called metallothionein, which I had written over there. They combine with them and make them harmless. So that is one of the safety thing given by the nature to the earthworms to do. And especially these few three species, and there is one also in Australia also I got over there, which commonly known as red worm. They are some of the species which can tolerate any amount of toxic chemicals and convert them into a harmless structure through combining them with this metallothioneins. So that is the thing. That is why the earthworms we were able to even treat some of the toxic wastewater and convert them into completely non-toxic and disinfected, detoxified, nutritive water for the farmers.
Great. Thank you very much indeed. It's been a great honor for you to join us. Thank you for joining us today.
Thank you.
We will make sure the link to your YouTube video is circulated to the delegates.
Be in contact with me through the emails, whatever question you have on entire vermiculture system. Okay. Thank you very much.
Thank you for joining us. Thank you. Okay, welcome back everybody. I hope you made good use of that short break. A couple of housekeeping items. Occasionally I have seen some of our audience members raise their hands. Unfortunately, we can't then invite you to participate in a particular way. So please, if you do have questions, put them in the Q&A box and we'll try and raise them with the panelists as we can and as there is time. As I mentioned at the beginning, if it's not possible to answer all the questions during today's session live, we will of course email answer to those to the whole group afterwards. We will also seek the presenters' permission to share their presentations, and they will be distributed if possible again after this event. So the first session was really an introduction to the topic, an introduction to INNOQUA and the lumber filter in India, and then a very nice introduction to some of the commercial aspects. And now, from my perspective, we get into the real nitty-gritty of the conference, the commercial, and then after the commercial, the research experiences in India itself. So without any further ado, it gives me great pleasure to welcome Ajit Oak to the platform. And Ajit, the floor is yours.
Thanks, David. Good afternoon and good morning and good evening, everybody, wherever we are around the world. So my name is Ajit Oak. I work with an organization called TBF Environmental Solutions, and I'm just going to share my screen and start my presentation. Give me a second. So can everybody see my screen?
Yes, indeed.
Well, just okay. So as I said, I work with TBF Environmental Solutions, which is a company based in India, in Pune. We are in the business of wastewater and fecal sludge treatment. Just to highlight before we start, we won a very prestigious Sarpati Sanitation Award at the Amsterdam International Water Week for our vermifiltration technology as the sort of most promising entrepreneur. So just wanted to highlight that this is also started to get international recognition now. So yeah, I mean, I will not spend too much time on the technical side of things, as most of us, have been working on this, I suppose. So yeah, we use tiger worm, Icena fetida. That's why we call our technology tiger biofilter technology. So we have tiger toilets and STPs and fecal sludge treatment plants. So basically, we all know these worms. They are basically composting worms, and they help in decomposition of organic matter very rapidly and very efficient ones. You can find subspecies in almost all parts of the world. So they are not sort of intrusive in most parts of the world. And we all know that this worm ecosystem operates on a self-regulating basis. So it's a very handy kind of animal to have to decompose your waste. So what we have, I'll just give a brief introduction on the products we have, and then we'll talk about a bit about commercialization and scaling up that we're trying to do here in India. So we have 4 major sort of lines of products. One is the toilet, which we started with back in 2013-14. So this is basically a digester. You see one form of it right now in the picture on the left, but there are other forms also which basically receives waste from the toilet and decomposes it on site. Very rapid, very efficient. We've installed close to 5,000 toilets now around the country in 11 states. So sort of it's been tested at different locations. Moving on from there, we try to scale this up, and we developed sewage treatment plants based on the same vermifiltration approach. So we have and sort of a smaller apartment scale, or let's say a small community scale or a factory scale unit, and we also have larger STPs scale units. You can see the 2 pictures here, the smaller ones and the bigger plant as well. And we also have developed recently, which I think is the most promising sort of use of this technology for us, at least, is the fecal sludge treatment plants. And so we are now installing quite a few of them. So you see a picture of one of them on top. So these are the 4 lines of products, and we have been trying to commercialize this since, let's say, 15-16, after we found our toilets to be pretty efficient in treatment. So just looking at, I was just trying to think in terms of what are the key components that you need to have. And then I'll try to go through each one in terms of where we stand on this and what we're trying to do. So maybe then we can discuss around them. So first and foremost, of course, you need an effective technology. In our context, something that meets the criteria is sort of acceptable cost and O&M wise, most optimal kind of thing, and which can also be adapted to various situations. Then you need the right certifications, you need the academic recognition for the technology in order to introduce this new thing in the market and try to scale up. So that's another certifications and academic recognition is an important factor, I think. You need a strong IP, not just in the sense of protection, but also you need an IP that truly has some substance, which means that you ought to have made some pretty solid innovation. Then you have that advantage of when you're trying to scale up, and of course having the legal backup of IP protection. Then another thing I find is that you need to have a sort of an application for your product, where you can really prove and you can really dominate in that small segment of the market, whatever niche market it might be. That I think helps you to sort of spread around, and that's what we're trying to do in one way or the other. You need a strong team, of course. You need very dedicated team, especially in this line of business. So you're talking about waste treatment. So very high committed individuals are required who can go on the long run when you're trying to introduce something new. You need favorable environment, in the sense government policies and market conditions in order to grow. And of course, you need to forge some good partnerships, and you need funding when you want to scale up and go beyond, sort of doing small scale projects. So just going through the technology very quickly. So as I said, toilets, we started installing them in 2014-15, and we found them to be very effective. So these were sort of decomposing the waste within 8 to 24 hours that we find. I've got a picture of a digester looking inside. This has been in use for 4 years, and you can see how this is actively being used, kind of a digester. So we took encouragement from that, and we tried to expand that. However, we found that it's really difficult to scale up a technology like this, which has got such a small scale operation. When you're trying to sort of install an individual toilet or individual toilet digester, we did find it pretty tricky to scale up. And so we are looking at new ways to do that. One of them is to basically making the designs, license them and make them basically freely available to people, so that the whole thing gets utilized more and more. So that's the approach that we are trying to kind of get. Then we came to the STP part, and here also, so we have these small scale units which you see here, fitted in a parking lot in an apartment building, and you see these large ones, which is a 500,000 liter capacity STP. So these have different applications, different markets, and different ways to sell, and of course service the industry as well. So there are you would definitely need partnerships and different kind of approaches to try and propagate these and scale these up to a sizable level. So in terms of when we talk about your technology being solid and strong, so we've got these effluent test summaries from our sewage treatment plants, and I think we're fairly good there in the sense of COD, BOD reductions that we've been able to achieve, and these are quite consistent across last 2 or 3 years. I mean, our oldest sewage treatment plants are now 3 years old, running continuously. Our toilets are more than 6 year old, the first ones that we built. So they have now, I think, tested, sort of stood the test of time, and the results that we've got are fairly good. So we feel more confident now to kind of go out there and try and scale this up. We've tried to do interactions with academic institutions, and we've got several papers published which are available online also, which give different dimensions of this vermifiltration technology, and that also helps us when we are talking to clients and discussing about the effectiveness of the technology. We've got some patents filed. We've got some under process. So there are about 4 patents which are being discussed. We're also being approved by the Mashelkar committee, which was a committee in India looking after the Swachh Bharat mission technologies. So that also has proved helpful for us to expand. Coming to the fecal sludge treatment that I mentioned right now, the current practices, we know these tanks, vacuum trucks which empty these septic tanks, and there are so many towns and cities where these trucks empty these tanks and then they dispose them off anywhere that they wish. And this is basically a need of the hour to provide solutions, and also a big opportunity in terms of business. And we are trying to basically go there and establish ourselves as the sort of an important service provider or technology provider in this fecal sludge management space. We've got now 3 plants operational, 2 in Kerala and 1 in Maharashtra, and we have a number of plants being constructed in UP. So where we are doing construction as well as operation maintenance for 7 hours, including collection systems. So these fecal sludge treatment plants, if I just quickly go through these, we collect the sludge in these top tanks here, which comes from the trucks, and then it sort of goes through these 3 sort of series of tanks, which are basically anaerobic stages. Coming from there, this is taken to vermifiltration beds, which is the first sort of series of filtration which holds a lot of solids, and the earthworms thrive and grow here and decompose the organic matter. And then it is passed through another series of vermifiltration, which you see in the crates out here, and the results are there in that picture at different stages of the treatment. And this has actually improved over the years. This is a picture when we had just commissioned this plant. Now we've been getting consistently good results. So CSE, the Center for Science and Environment, did a study for our plant, and they looked at the quality parameters, and we got pretty good results from this FSTP. You can see the inlet parameters for COD and the outlet parameters, inlet parameters for BOD, which range which are 15,000 to even as high as 40,000 at times, and we've been able to got them down mostly to under 10. So which is I think a pretty good achievement in the sense that you're doing this with a completely natural process with almost zero power. The only power we require is to lift the waste from point A to point B, where it's not possible to be taken by gravity. Similarly, the nutrient also, we've been able to reduce that substantially. Phosphates, I got TKN, I've got even fecal coliform. Of course, we were disinfecting at the end, but these are the sort of output that we've given. So encouraged by that, we are sort of looking at trying to establish ourselves and trying to be aggressive on this FSTP front. There's a lot of market available. There's a need in the for the environment as well, that there have to be some effective solutions. CDD has excellent designs, and we try to sort of adopt some of their principles as well as what we have learned from our vermifiltration experience. So I think it's come out to be a very effective design as such. In terms of market opportunity, I think there is, with the Swachh Bharat 2 mission saying that you require a fecal sludge plant every district, and there is a per capita cost norm which is reasonable, and you can do good work in that. So I think there is a big opportunity there which can be harnessed, especially for fecal sludge treatment plants. And if you have solutions which are nature based and effective in terms of operation maintenance. Yeah, we try to sort of also be involved in the news, and we have been covered at a through a number of newspapers as well as through different web-based news agencies. So coming back to this, potential is huge in India. I think there is a large number of upcoming towns and villages where this aspirational alternative to pit latrines and septic tanks. People want something new and something that can effectively decompose the waste. We found that it's a question of how you actually try and scale this up for a small scale solution like a single toilet. Also, these stricter pollution norms means that large number of STPs are needed, decentralized as well as big ones, and there is a definite demand for that. And again, if we can provide some solutions which is cheaper to and easier to operate, I think people want that. If we had recently exhibited our technology in a construction exhibition, and we got so many queries looking to basically find answers to broken down or closed down sewage treatment plants. So people are really struggling with mechanized STPs and things that are expensive to operate or difficult to operate. And if we can provide that solution there, I think there is a big scope to expand in that market as well. Also, water recycling solutions, especially for institutional and industrial clients. We've got a lot of inquiries on that, and we've provided solutions for recycling for use in gardens mainly, so at a couple of places for flushing as well. So with more and more stricter norms on how much water you can use in new developments, I think this is another potential. So looking at adopting this vermifiltration technology and marrying it to further tertiary treatment options, so that you can get a higher quality of output which can be recycled, would be something that we need to look at as well. And as I said, fecal sludge management is an urgent need, and there is a lot of scope to expand on that front as well. So where we are at the moment, we've done about 5,000 toilets. we did execute under the Swachh Bharat mission the retrofitting of digesters also in Karnataka, which is also a large number that needs to be done across the country. We've been empaneled by the Swachh Bharat mission. So we've got several STPs already constructed, which I mentioned earlier, fecal sludge plant. We have recently started going out.
Please,
we installed our first plants in Hawaii in March, just before things got locked down, and that plant is under testing, and hopefully in a few months' time we should be able to offer an international sort of solution, which would be approved by the US authorities for local decentralized waste treatment. We've got some pretty strong order board at this moment, and we're trying to expand, as I said, on the more on the fecal sludge side of things, trying to identify partners for small scale STPs. We are looking at licensing the Tiger Toilet digesters widely, for and making these designs readily available to local masons. So we are talking to some self-help groups and others who can actually promote that. And we are looking at partnerships for STPs as well as FSTP construction. So, and of course, in the sense that what we basically expecting to have is, more investment, more funding to be able to expand. And also, since a lot of this work of large scale plants involves government tendering, we are hoping that we get a more level playing field, because of the fact that we are bringing in a new technology which doesn't have a lot of history of a lot of installations, but it has proven itself over substantially proven itself. So that should be allowed and that should be encouraged. So those are the two things that I had to say on sort of what we are looking for in order to scale up and expand. So that's it from me. Thanks. Any questions?
Great. Thank you very much indeed. There are some questions in the Q&A box, so if you have a chance to look at those after, that would be fantastic. I will raise briefly just two, if I might. The first one is, can you say what the hydraulic retention time is for the fecal sludge plant you showed us? I think possibly in Kerala, that plant?
Yes. Yeah, so including the anaerobic stage, the current design that we have has a 3-day anaerobic retention, which achieves your mixing, homogenization, as well as some sort of anaerobic decomposition. And rest is, of course, the vertical flow filters. So that's more or less like passing straight through. So you can say 3 days and a bit.
Okay, thank you. And a more general question from my side. Do these systems need special operational skills, do you find, and or do you need to provide additional training when you install and operate these kind of systems?
No, no. We found that it's pretty basic knowledge that you need to give. So basically, it's either it's STP or FSTP. You are looking at switching on and off a few pumps maybe, and opening and closing of a few valves, and doing a set of operations which are laid out in SOPs, and looking at signals to improvise things if required. So that's basically, so our plants typically are run by one sort of plant in charge who's more sort of trained, and one help with him. So that's about it basically.
Perfect. Thank you. So thank you very much indeed for your presentation, and I think we'll be welcoming you back for the panel discussion later this afternoon. Ajit, thank you very much indeed. So it gives me great pleasure now to hand over to Mr. Rahul Chabra from Transchem. The floor is yours, sir.
Good afternoon, everybody. It's a pleasure to be a part of such an august conference, and to be among such international speakers. Today we will be representing. Today we'll be representing TransBioFilter, which is basically a technology we have developed in-house, of course, which is worked upon the research done by Dr. Sinha, as he previously mentioned. And so I would be taking through the company and a little bit background about the research and the work we've done. And then Mandar Prabhune, who's our technology head, would be covering up the advanced work we've done with the technology in terms of industrial effluent. So I'll just share my screen and start the presentation. Yeah, so basically, TransBioFilter is a technology which is developed by Shroff group of companies, which is spearheaded by Shri Atul Shroff. So this is a chemical manufacturing group, $1 billion group in India. And this is more of a product which is developed out of the passion of Mr. Atul Shroff, who wanted to create a green, sustainable technology. And as you all are aware, there is very few research work which has happened in India in terms of wastewater treatment. And like Ajit has developed something, and IIT Mumbai has done Chandrasekhar, and of course we have done a lot of work on the development of a technology. So we are a company which is focused on agriculture related products and wastewater treatment through our technology TransBioFilter. So of course, everybody is aware of the background in terms of the problems in India and of course the world, where the it's all water stressed and there is hardly any development that's happening, any treatment that's happening in India. So as per a recent survey, we came to know that only 20% of the sewage generated actually gets treated in India. So I will just like to harp upon decentralized, because primarily India is a developing country and we cannot really afford expensive lines to set up wastewater treatment, wastewater collection, and of course mega MLD treatment plants. So we realized that for a country like India, decentralized wastewater treatment is the solution. We've also recently working with a builder for a township in near Pune, and so it's a township which was coming out with a 1 MLD sewage treatment plant. Instead of 1 MLD sewage plant, now they are coming out with several decentralized wastewater treatment plants. So every bungalow or a row house would have a sewage treatment plant, and the water will be reused in the garden of that bungalow. So jointly we worked out, and it is saving the developer around 60% of the project cost. It's because it saved money of laying the pipelines to take the dirty water back, and of course heavy capital expenditure and set up a big plant. So decentralized is what our focus is what is the need of the country right now, and that's where we've done a lot of work on. About TransBioFilters, so it's as the august speakers and the researchers, the people who develop the technology are aware that it's basically organic media, which is dosed with specialized earthworms and selected microbial culture. It's based on adsorption method, and the water is sprinkled on it, and it's a trickling filter, and the water trickles down through gravity, and while it trickles down, it gets treated. So we've won a lot of awards for the same, including the Best Technology Award through Fecal in 2018. And also the technology is patent pending. We would be getting our patents in another 3 to 4 months for the system that we've designed. The segments we are in, so in the STP segment, we are in residential complexes, commercial establishment, institutes, colleges, resorts, and religious places. Apart from that, we've done a lot of work in industrial effluent treatment, and we have been successful in chemical, block dye, sugar, dairy, food processing, and fisheries industries. Again, a small comparison, a conventional ETP or an STP, which involves a lot of stages, chemical dosing, and on the right, you see the biofilter, which is a very simple system. The water is sprayed onto the bed, and rest happens through gravity and the nature. Again, a lot of advantages, but main of the advantages which I would like to highlight is that unlike conventional system, there is no sludge generation that happens in the system. There is no odor because ammonia actually gets consumed in the system, and there is no water that is exposed to the air beyond a couple of seconds while between the sprinkler and the bed. And the most beautiful advantage, I would say, is the variable hydraulic load, because when you talk about decentralized STP, for example, college, so, 2 to 3 months in a year, the plant is operational only at 10 to 15% of the capacity, at which time the conventional technologies don't do the treatment. But with biofilter, what we have observed is it works at even 5% of the hydraulic load design basis. So that's a very good advantage. And apart from this, in our experience with handling industrial effluent, we've seen that the technology works even in TDS presence of up to 20,000 TDS, which is, so of course the TDS is not getting reduced, but the COD load gets reduced even up to 20,000 TDS. So we've done a lot of research. We started with 300 liters per square meter in I would say the year 2000, and today we are at 6,000 liters per square meter. So that is the advancement we've done over the last couple of years. Now again, in decentralized, people want a very compact, modular, packaged STP. They really don't want to invest in civil works and have an open area. So this is the new innovation that we've done, where the plant is now very compact, and it comes on a skid, and it's more of a plug and play. So the plant can virtually be installed in 6 hours in anywhere in the country. Now, just to give you an idea, a 10 KLD or a 10,000 liters per day plant takes only 4.5 square meter of area, right? Which is very, very compact. A 40 KLD is getting done in 12 square meters. This includes everything, the plant area and little bit area of the maintenance. This is just a picture of the modular plants. So if you see on the left is the yellow one is the 10,000 liters per day modular plant, which includes up to tertiary treatment. And on the right, you see is a 40,000 liter per day modular plant. Some of installation. So what you see on the left top end is the generation 1 modular plant that we created, which was a multi-story plant. Of course, we are at generation 3 now. And on the right that you see is the civil-based plants, the big plants like a 1 MLD. And on the top right, on the bottom right picture that you see is a lagoon-based plant, which we have developed for rural areas in India. Because in a rural area in India, there is a problem of theft of the elements of the plant. So this is a plant that we've created using local material for creating that lagoon, and the media is inside. So there is virtually no danger of theft. And as well as that, the media that we use is locally available and sourced. So all the material that you see in the plant is locally sourced from the village. So this is another interesting study where it was an MBBR plant of a client, which was not working as per the designed parameters. And we could install the plants in 1.5 days, or you can say 2 days, so a 30,000 liter plant, which was defunct, could be made operational using biofilter module plants in just 2 days. This is how the layers are. So what we've done is the development or the research has gone in creating these layers to improve the efficiency of the system. This is another plant which with the tertiary treatment. So this is installed in an apartment in Gujarat. So it's a 10,000 liter plant, which the sewage is treated, and then of course is subjected to a nanofilter because the TDS is low here. The accept of the nanofilter goes in car washing, in the washing in the apartment, and the reject of the nanofilter, which is nothing but rich nutrient-rich water, is used in the gardening. I've covered that. So this is another interesting case study where in Bhavnagar, one of our clients, they wanted to do under the CSR project. So they were basically buying 1 MLD of water every day. And there was a nearby dirty water line near their factory, right? So they realized that instead of buying the water every day, why don't we tap the water from the sewage line that passes near the factory and treat it and use it for our use. So basically they installed a biofilter. We extracted 1 MLD of water from the sewage line, treated with biofilter, and of course subjected it to tertiary treatment. And although the project initially was conceptualized against their CSR objective, but if you see, they broke even the project cost in less than 9 months. Because they were buying water earlier, which was of high TDS, and they were treating it before use. And instead of that, when they were tapping sewage and treating it and subjecting it to multi-stage RO within the tertiary treatment, still they could break even the project cost in another 6 months. Some of the results of, so inlet was 200 to 400. After the biofilter, it was less than 20, and the norms on the right. This is again a very interesting case study where in Jalna, which is a rural area in Maharashtra in Western India. So this was a agriculture center, NGO, which had an agriculture center for that district. They did not have any water to do the farming because of the low groundwater levels. And this area was not connected with electricity. So we went by, again, we tapped the water from a nearby sewage line. The whole plant is working on solar system. So there was no external power that was required, and there was no water required because we were tapping in sewage, right? So from there, so they were doing around 2 fodder crops a year. That's it. Because of installing biofilter, which was a self-sustained plant, they could do 7 different type of fruits, 6 different type of vegetables, and the fodder yield also increased by 5 to 6 times, apart from the other benefits. So some of the pictures of, so this was an arid land which there was hardly any farming done, and post biofilter, these are the results. So again, the nutrient conversion in transbiofilter in our assessment, 800 meter cube or 800 KLD plant per day gives nitrogen equivalent to 28 tons of urea, 4 tons of DAP, and 12 tons of potash. So this is the equivalent of available nutrients that are available in the treated water with biofilter. I'll quickly take you through this interesting case study. This is again Khanderapura in rural India. Let me just keep tapping the time. Where this was cholera prone area, that is the waterborne diseases were there because the STP was not, the sewage was not treated in the village. And we went in. This is a plant that we've installed inside the school of that village. And the right shed that you see is actually the area where children sit and eat. So this is the plant that's working. There is no odor, whatever. There is no fly. There is no foul smell, nothing. And the water is getting treated and it's used for agriculture. And in fact, the most interesting thing I would like to point out here is that conventionally we think that STPs are a cost center, right? But here is a fact, which is a study done by a very senior Indian Forest Services officer of 59 batch in India, Mr. R.K. Sama. He's deduced that if transbiofilter is installed in a rural setup where the sewage is collected, treated, and used for agriculture, the rural economy of the village gets a benefit of 18 rupees per 1,000 liter treatment of water, wastewater. And even if we reduce cost of 4 rupees per 1,000 liter of treatment, still the economy of the village is benefiting by 14 rupees for every 1,000 liter water treated. So this is a very mind-boggling figure that's come out, and we're trying to replicate it in Gujarat across the district and the villages. In fact, the government of Gujarat has approached us to replicate this model everywhere. And Chikodra is a village which is so it's a 1 lakh liter or 100,000 liter STP in a village that we've installed in Chikodra. And for such a small project also, the Honorable Chief Minister of Gujarat personally came to inaugurate this plant because he loves this idea. So this is how the plant is. It's only in 81 square meters, we could do 100,000 liters per day of sewage treatment. The new model plant, of course. Another plant we've installed in Delhi to demonstrate is toilet to tap. That is, the toilet water goes up to the drinking water levels, which was inaugurated by the Honorable Chief Minister of New Delhi, Mr. Kejriwal. This is 80,000 liter per day plant. Again, this is working completely on solar. There is no external electricity required, even for the tertiary treatment. So fecal sludge treatment, of course, this is also a possibility with biofilter. We are in collaboration with TBF from Pune only for the fecal sludge treatment, which is a big opportunity in India, wherein the mandate is that all the septic tanks has to be cleaned, and wherever the sewage network is not there and has to be collected and taken to a plant and treated it. So biofilter, in our experience, we've seen that can reduce the capital cost by 80% if biofilter as a technology is used in fecal sludge treatment compared to conventional. Now, for industrial wastewater, I'll ask my colleague Mandar Prabhune to
2 minutes, please. Thank you.
Take it forward. Mandar, only 2 minutes are there, so please rise up. You want to take my start?
Yeah. Hello. So after getting the success in terms of the municipal and the domestic wastewater, we also explored the technology for various industrial waste water. Some of the commercial installations of our ETPs are for chemical wastewater, for dairy industry, for dye industry. So we have installed more than around 5-6 ETPs till date. And wonderfully, we are also working on some of the basic chemical contaminants which are very toxic in nature, and how vermifiltration or the earthworms can tolerate these contaminants, and not only tolerate but also degrade them drastically. And that is how these are some of the contaminants like phenolic compounds, sulfides, all those can be treated through vermifiltration. Just to give an example of phenolic wastewater, we have treated almost input phenol concentration of around 1300 ppm and brought down to less than 1 ppm. So that is the way the vermifiltration works, and that is the capability of the earthworms to degrade these toxic chemicals. Even various wastewaters from polymer industry also we have done successful case studies. So the organic loadings up to 12,000 of COD. So basically vermifiltration can handle very high concentration of organic loads, and that is how the breakdown of the chemical components takes place in the vermifiltration technology. These are also some of the case studies of chemical industry only, where the organic loading in terms of the COD was around up to 25,000 milligrams per liter and was reduced to 250 ppm. Next. Also nowadays, since the ZLD is one of the concepts, that is zero liquid discharge. So people install multi-evaporator systems, but from that there is a condensate which is coming out, and that is how the condensate also needs to be treated, and vermifiltration can do wonders in treating condensate effluents also. Even the cheeseway also has very high organic loading. This is one of the wonderful case studies where we have converted the conventional effluent treatment plant into biofilter. So you can see the footprint area, how it has reduced from 3,000 square meters to 400 square meters. And also it has reduced the operational cost to more than around 65 to 70% in terms of the power requirement, and also the operation in terms of maintenance. And of course, the retention time has reduced from 10 days to 45 minutes. One of the another innovations what we are being done is the air biofilter. So like wastewater, the air emissions which are coming out from the industrial setups or from the sewage, centralized sewage treatment plants, the major emissions are in terms of VOCs, the ammonia, the sulfide. So the biofilter also can work very well for absorbing the air emissions, and you can get a very clean air in the atmosphere, and all the greenhouse gases can be reduced. So this can be also one of the most important aspects of the vermifiltration system.
Yeah, so that's a quick representation of what we're doing. And before we end, I would like to just mention that we have a very extensive research and development facility in Gujarat, where we have permission from the Pollution Control Board to bring in effluent every day up to 2,000 liters and do a treatability study. That's how we work. So we would like to invite anybody who wants to enter India, anybody who wants to do any trials, testing, to collaborate with us, and we would be more than happy to share our learnings and learn something new along the way. Thank you. Over to you, Dave.
A very, very brilliant overview of the applications of that technology. Thank you very much indeed. Those examples were very stimulating, and they show how versatile vermifiltration is in practical terms. We have a number of questions in the chat box, which I'll be very grateful if you could come to when we've moved on to the next speaker. But just one quick question from my side, and it's around the replacement or accumulation of biomass in your filter layers. So in terms of maintenance, do you have to take away some biomass periodically, or is it really genuinely self-sustaining? So there's once the system is operating, you don't need to intervene in the filter layers at all.
Yeah. So in our system, we usually replace media once a year, right? So the media over a period of time gets degraded and gets converted into vermicompost. So in terms of the earthworms and the microbes, that is self-generation. Your mic is on. So in terms of earthworms and microbes, that's self-generating. So one earthworm becomes 256 earthworms in 1.5 years. And once they die, the earthworms eat themselves up. So it's one of the most beautiful species in the world. And in terms of the media, it gets degraded and still has that essential microbes for the treatment. But it always helps when we put in fresh media and take out the vermicompost, and then it can be used for gardening. So that's what we do.
Perfect. Thank you very much indeed. please, if you'd like to address the questions, and thank you for making the offer to show your facility, make your facility available to others. I'm sure that you'll have some takers for that very kind offer. So thank you very much indeed again. And before I move on to our next speaker, Sudipti, just to make everyone aware that you are able to ask questions for individual speakers in the chat box. So if you would like a particular speaker to address your question, please just use the facility in the chat box. At that point, it gives me great pleasure to hand over to you, Sudipti. So the floor is yours.
Thank you so much, David. So basically, first of all, I would like to thank each one of the organizers for this very wonderful conference. And I'm really, so it's really inciting that we got so much of knowledge about vermifiltration today. So I'm just sharing my screen. So basically, I'm Dr. Sudipti Arora. I'm working as a research scientist in Dr. Bilal Institute of Biotechnology, Jaipur. So, and about today's conference, so my topic would be mainly focusing on the investigations of the dynamic mechanisms of earthworms and microorganism interaction for wastewater treatment by vermifiltration technology. So I have done my PhD from IIT Roorkee, and I've done my master's in environmental engineering from MNIT Jaipur, and I've been working on this field of vermifiltration since last 8 years now. And also I am a founder of Prakrit. Prakrit is basically a center of excellence that is working in environmental biotechnology, completely dedicated towards achieving sustainable development goals for the wastewater treatment, for the solid waste management. And so my area of expertise is mainly pathogen surveillance and environmental microbiology and molecular biology. So these are the content of my today's presentation, and morely I'll be focusing on my research insights in last years and the mechanism that I try to decipher, between the lines, that how the vermifiltration technology is working, how beautifully it is working. So what's the role of the earthworms and microflora behind all this process? So as our speakers have showed us a lot of, commercialized product that is already available in the market. But being a researcher, I know that a lot of R&D always goes behind the scene. So firstly, before beginning to my presentation, I would like to give a lot of gratitude to Dr. Rajiv Sinha, who was a pioneer, who is a pioneer, and who was my mentor. And because when I was in my PhD and I was reading and I was just beginning my research career, so I was fortunate to even get some reply from that I gave to his, and I got really good replies from him. And then I started my journey of vermifiltration technology. So I'm really grateful to you, sir. And also I've been reading a lot of researches and that you have been doing. So we know this very unfortunate thing, that's a challenging thing, that this is the sad reality, that water is a scarce resource now, and a lot of sewage treatment plants are already there, but due to the cost and due to some other factors, it's not in reality. If it look to the rural population of India especially, they are suffering a lot from the waterborne diseases. So it's a dream for them to have a sewage treatment plant. That's a dream, because they don't even have the basic facilities of sanitation and hygiene, if I talk about. And that's my personal experience when I'm working in the rural sector as well. So yes, there's definitely an opportunity. There's a need to, have a novel, innovative solution that is that demands less operation and maintenance. That's an easy solution that people could easily understand, and more importantly, it is efficient, effective, and affordable. So that's the solution we are talking about here, and we all are talking about, and we know all the gold merit of this technology, vermifiltration technology. Earthworms, no doubt, have been regarded as the farmer's friend since many million of years now, and they have been doing wonderful work of treating our pollution from since many years. So we know that that's their favorite food, and they degrade all the organic matter, converting these organics into some useful products for us. And so basically, if we talk about it scientifically, so we know that the body of the earthworm acts as a biofilter, and through the enzymatic activity and the antimicrobial activity that the microflora inside the earthworms generate will definitely help in the treatment of the wastewater. So this is a simple schematic representation to show that how the water, along with some solid waste that we put into the vermifilter for the earthworms, so they degrade the organics, they remove the pathogens and convert the waste into very useful products. So we get treated effluent that we can use for non-potable purposes and vermicompost. The basic design includes the optimal hydraulic loading rate, hydraulic retention time, the type of species that we are putting it. The number of species is equally important along with the type of species, organic loading rate to maintain the food ratio, the healthy status of the earthworms, the filter media that we are choosing, along with appropriate environmental conditions. So these all factors are really important when we talk about the design. And yes, lot of studies have now shown the removal efficacy of the pollutant is considerably significant, and we can use these bioproducts from the vermifilter. And the very important parameter, very important aspect about this technology is that it is scalable. So right from a small vermifilter, we can scale up to a large sewage treatment plant that you have already seen in the previous speakers have also highlighted this thing. Let me talk about what goes inside a vermifilter plant for its functioning. So basically, it's a very simple design with maximum benefits. So because the earthworms does this job by the symbiotic and synergistic interactions with microorganisms, and all we need is the appropriate filter media for the earthworms. So they work very well in this vermi grating along with some cow dung and some organic material that we feed at the top, and we call it as the active layer, where they are actively working on our waste, followed by some supporting media, which is usually riverbed materials that we use here. So I've been working in this technology since last 8 years now, and right from designing a very small lab scale vermifilter and try to find out the research insights of the vermifilter, now my focus is shifting towards mainly application part. So I'll show you my journey, that how I've been working on through these several years in a very quick mode. So this was my laboratory, the first setup that we did in IT Roorkee. That was a very small setup, but basically, firstly, the aim was just to develop a design criteria. Based on the previous research studies, we designed a suitable design criteria. So our first run mainly included applying with different stocking density of the earthworms, and based upon the results of BOD, COD and pathogen removal, we are able to find that the optimum stocking density can be ranging from 8 to 10,000, and that was also shown by the previous researchers. Then coming to different filter media, we optimized gravels, filter bed material, coal, some activated coal also we put in, some mud balls and glass balls. So each of these filter media definitely showed a very good treatment efficacy in terms of significant parameter removal. But considering every factor based and also the health of the earthworms later after the vermifiltration, we came out to be, so we concluded that river bed material works best. There's no doubt about that. Then in the third run, we optimized the different hydraulic loading rate and different OLRs. And then we also gave up the final optimized design criteria. And these all papers also have been published now. Then the phase 2 of the study was to install a pilot scale vermifilter that could run for for 1 year and all the 4 seasons. So that was the important aspect of this study. There were 2 aspects. One was to compare vermifilter with a geofilter. So the half of the vermifilter was the control where earthworms were not put, and the other half was where earthworms were added. So we tried to find out the difference. That we basically wanted to research on what impact earthworms does to this treatment efficacy. And based upon that, we were able to find out that yes, definitely the reduction in terms of BOD and COD is more in vermifilter where there are earthworms as compared to without earthworms. Because in biofilter, we will say that there is only microorganisms majorly that take place, but here earthworms and microorganisms plays, they multiply their role, they play a dual role, they support each other. And that study also we were able to decipher. I'll show you in my later slides that how the impact of microflora is on the earthworm and how earthworms impact the microflora, their inherent microflora. So all the pathogens like Salmonella, E. coli, actinomycetes were considerably removed. And then the other phase of the study where we tried to, co-treat. So what we did, we at the top layer, we put some organic fraction of biodegradable solid waste. That was the canteen waste from the hostel we collected. We partially degraded it and put it to the top of the vermifilter. The idea was just to see whether the earthworm, vermicomposting and vermifilter could take place together, so that maybe if we go for a decentralized setup in the future, we can make up at one place the two things can be done together or not. So yes, we published that study also, and we found good results in terms of ammonia removal, nitrate, and the CN ratio. That shows that how our organic waste is now converted into vermicompost. Pathogens and all the parameters were reduced. Microbiological analysis was also done. Then very important part, that was the highlight of my research basically, that we tried to find out the microbial diversity from different layers of vermifilter and also from the earthworms. So we wanted to check that what impact, which of the microflora is more responsible, the one that is present in the sewage, one that is present in the vermifilter, or one that is present inside the earthworms. So for that, we did different set of experiments. There were some earthworms which were not put into the vermifilter. We call them as the control earthworms. So we isolated few microflora from them. Then we also isolated from different filter bed, and then lastly from the coelomic fluid. So without harming any of the earthworms, we isolated the coelomic fluid, giving them the cold shock treatment, and were able to isolate microflora. And I'll show you the result in my next slide. This slide shows the phylogenetics. So basically we found the relationship between different microflora and how the specialized microflora that went into the earthworms take a major role in the treatment. That was the highlight that we were able to find out. And lastly, now this vermifilter, after the pilot scale, this is a field scale vermifilter which was operated since 2016. So it's 4 years now, it's working fine. And we have designed this vermifilter for two kinds of wastewater. So one is the institution wastewater, Dr. Bilal Institute, where I work, and the other is the clinical laboratory. So that was the highlight, because as such, I could not find much of these studies on vermifilter for hospital and clinical laboratory wastewater. So we did this and we found great results. This was the slide. Maybe it's not clear right now, but this slide shows the microflora that is isolated from influent, effluent, earthworms, earthworm gut, earthworm coelomic fluid, and filter media. So these are the results. So we can see very interesting result here, that when the bacterial diversity in the influent was 50% gram positive, 50% gram negative, but from the earthworms, where they were not inoculated, their microbial diversity was different. But when they were inoculated into the vermifilter, they considerably showed some interesting results. So that means that earthworms do need some acclimatization time when they go into the vermifilter, and after that, with the influent, their characteristics changes, their properties changes. We also try to find out the antibacterial effect, the enzymatic effect, and the activity, that which microflora is more responsible for the treatment, so that maybe in the future we could improve and make it a more innovative technology in terms of specialized microflora that we can add. So that was a very interesting results we got. And one major finding was with the clinical laboratory, because there is a lot of concern about AMR. We have been reading it that AMR is now at the spread. So I just wanted to check that when we talk about antibiotics, do earthworms have any effect on the spread of antibiotic resistance? Because we have also read that STPs are responsible for AMR somehow. So we got really good results here. We did a study on different classes of antibiotics, and we have seen that how earthworms, through their So this is the basically the mechanism that how earthworms in their gut with the gut microflora changes the resistivity pattern. So we found that the effluent that is coming out from the vermifilter showed less resistance. So species somehow become sensitive towards antibiotic, and that's a breakthrough if we talk about the clinical and hospital wastewater. We are still investigating it more in detail. We have done this in the terms of antibiotic genes also. So we are trying to decipher more of this. And finally, over
2 minutes.
yeah. So finally, over several years of my research experience, I am able to decipher the mechanism. So because my role as a researcher is to try to find out that yes, we know that it is taking place, but how? Which microorganisms are more playing as a key player role? How earthworms is doing this? So that's my insights and contribution towards this field. Also, I've been testing it for institutional, domestic, and clinical laboratory wastewater so far, and I'm able to decipher the role of microflora, how the symbiotic and synergistic interactions takes place between the vermifilter for the better treatment. And yes, there's no doubt about this technology. I've been working since last 8 years. Even I could not find any smell, odor problem or any clogging problem. They work wonder in the wastewater. They just love wastewater, and they are able to co-treat the wastewater as well. So that's the novelty about this technology, that it is bioengineered and customizable technology. It has a unique and specialized design. It has specialized microflora, and if we add that microflora, that will even add more value to our vermifilter. It has wide applicability. It is scalable. So this is my research, this is my team, and I have got good support from my mentors from IIT Roorkee and MNIT Jaipur. Then we have some civil engineers and also microbiologists, molecular biologists in my team. So we are able to do this much of research. These are some of my publications and some of my awards in the different conferences and different platforms. And at the last, I'm just happy to share that yes, through these research, I am able to solve the sustainable agenda goal number 3 and 6, and I'm really proud of it, because if somehow we are able to contribute towards environmental conservation, that's a great step towards humanity as well. So at the last, I would like to thank each one of you for listening, for and the conference organizers for organizing such a great conference. And I'm really looking forward to working with some of you for further. I'm also open for more collaborations in the future, and somehow even my dream is to take this technology from research to the for actual benefit for the people of society, for the people, and if we could apply this in real, and definitely the R&D will go on. That's all I have to say. Thank you so much, and I'm open for any questions if you have. Thank you.
Fantastic. Thank you very much indeed. There are a couple of questions in the chat box. I'll pick those out and add one of my own, which occurred to me during your presentation. The first one is, do you need to keep out earthworm predators from the system? So things that might predate the earthworms?
No, we are not. We do not want to keep any of these systems, because earthworms work in this very sustainable environment. They look onto their own things. They will degrade their own waste. So we do not specifically. We don't need anything special for them.
Yes, but do you need to exclude nematodes, for example, or other things that might attack the earthworms?
No. I don't. We don't need to do any of these things. They can predate on their own. They will work on their own.
Great, thank you. And the final question, you mentioned the acclimatization that was needed for your medical wastewaters. What kind of time scale are you talking for acclimatization of the earthworms?
So basically, firstly, we acclimatized our vermifilter for 20 days. We did not put any earthworms in it. So just to acclimatize the wastewater with the filter media. And then after adding earthworms, for a very little hydraulic load rate, we acclimatize it for another 21 days. And slowly we put on, because that we were doing it for the first time with the clinical wastewater. And we were really very worried, because no such studies have been done so far. So we were worried about the effect of antibiotics or something, or maybe some hazardous toxic compound. But it's very good that we could not find anything like that, and we got really good results.
Fantastic. Dr. Sudipti, thank you again for your presentation, and I look forward to speaking with you again on the panel discussion later today. Thank you again. So it now gives me great pleasure to hand over to our final speaker for this session, and that's to Dr. Chandrajit Kumar. So Dr. Kumar, the floor is yours. Welcome.
Hello, David. I am audible?
Yes, Dr. Kumar, welcome. Please feel free to share your screen if you like.
But I am not getting my video or camera. Please put it on. Yes. Okay. Namaskar, all of you. Thank you so much for inviting me at this platform. And I am so happy that CDD and INNOQUA has provided me this platform to just share my information. David, am I audible?
Yes, indeed. Please feel free to continue.
Okay, thank you. So just a moment, I'm going to share my screen. 1 minute. Okay.
At the bottom of your window, the screen share.
Yes, I am doing it.
Okay, works now.
Yeah. So before starting my slides, I want to show my gratitude towards my great mentor, Dr. Rajiv Kumar Sinha and Dr. Ashok Ghosh regarding the vermifiltration. Whatever knowledge I have, I actually gained it from the Dr. Rajiv Sinha and Dr. Ashok Ghosh. So I am grateful to both of them, just providing the good information and the knowledge about the earthworms and the vermifiltration. Basically, I am the student of biotechnology, and I was totally unaware from the role of earthworms. When we were studying the environmental biotechnology, we heard about the wastewater treatment and the sewage treatment. But at that time also, we never heard about the role of earthworms. And actually, no one professor or no one teacher introduced about the earthworms or the role of earthworms in the environment. And the role of earthworm just to treat the water. We heard about the vermicomposting, but we never heard about the vermifiltration. When I just started to pursue my PhD, then I just met with Dr. Rajiv Sinha sir, and he introduced me total information regarding earthworms and their vermifiltration. And in 2018, I completed my PhD from AN College, Patna. So, and just completing my PhD, Government of India UGC also funded me and provided me a scholarship just to pursue this PhD and just to complete this research work. Nowadays, I am working as an assistant professor, Department of Biotechnology, YVN University. As you can see, the logo is here. And as well as I am also working as a controller of examination at the same university. So these both are the my great mentor, Dr. Ashok Ghosh and the Dr. Rajiv Sinha sir, for whom I was talking right now. So my topic is for the slide is not coming. An innovation technology to make gold from garbage and silver from sewage. Actually, this is the popular slogan which I have taken from the Dr. Rajiv Sinha sir slide. Actually, I heard many times Dr. Rajiv Sinha sir, and this one word or this one slogan has always impressed me. Then I was basically thinking how one person can get gold from garbage and how any person can get silver from the sewage. So this is a very simple answer. Through the vermifiltration technology, by using earthworms, we can get gold from garbage as well as silver from the sewage. We since 2 p.m. we all are hearing about the vermifiltration technology and the basic problems nowadays society which we are facing. So I will not go much more around that. So I will briefly conclude my slide, and I want to share my some of the experiments which I have done in the vermifiltration technology field. I want to show my gratitude toward the Maria Soto, George Han, Upendra Patel, Dr. Ashok Ghosh, and I heard many times about the Transchem and the Transpec, but I never get an opportunity to visit that Transchem and then Transpec, and I never heard the persons from them, that company also. But I am so thankful that today I heard from that company persons also. So these are the some basic features of the vermifiltration technology and the role of earthworms, which we all know. Nothing to elaborate something more about this. One more thing, just I will tell. Nowadays, company or all over the throughout the world, some company has started using electricity, and they have included electricity also just to use the vermifiltration technology. But what I think, we should try our best not to use electricity just to run the vermifiltration technology, because the vermifiltration, the main specific function or the main specific feature of the vermifiltration technology is that the vermifiltration technology runs without use of electricity. And this is the main thing. If we save the electricity and if we run some commercial applications without using our electricity, that means this is a bigger opportunity or a bigger achievement for us. So these are the applications and advantages of vermifiltration technology. This is nothing new. We all knew about the advantages and the applications and where vermifiltration technology can be used and what are the various applications of the vermifiltration technology. We all are completely aware from that. I will discuss much only on two methods. First one is the fabrication of vermifiltration unit, which I have prepared one unit when I was pursuing my PhD. And using that vermifiltration unit, I filtered wastewater from that vermifiltration unit, and I gave one term the wastewater treated vermifilter treated water, that is VermiAQUA. So this is the first time when the VermiAQUA term is utilized. In my knowledge, when I was pursuing my PhD, there was no such term, that is VermiAQUA, and there in no research paper you can find the VermiAQUA. But with the work I have published in the Springer, you also can find me on the Springer publication. So my overall work is published on that journal, and you can find the term VermiAQUA. So I have terminated, or I have mentioned one term for the vermifiltered water, that is VermiAQUA. And there are 3 experiments. I used that VermiAQUA on the Oryza sativa, a rice crop. Again, I used that vermifiltered water on the Allium cepa, onion. And again, I used in my third experiment, I filtered arsenic contaminated water through the vermifiltration unit. And I will just briefly show you the results and the methodologies. This is my vermifiltration unit, which I have prepared or constructed by myself when I was pursuing my PhD. Before constructing this filter, one main thing is in my mind was that the filter should be such easy or accessible that anyone can make that filter. Filter should work, or filters, the principle of filter should work on the Fermi filtration technology. Principle should not be changed, but its economical value must be low. So any farmer, any poor farmer can construct that filter by himself, and there is no need such skill to just develop or to construct a very simple vermifiltration technology. And this is the sample which you all can see. This is the wastewater sample, and this is the vermifiltered VermiAqua, and this is filtered through this vermifiltration technology or vermifilter. This unit is an aerobic process in which you can see the microscopic view. So first layer is the mixture of earthworms, and the next various layers are composed of the chips and sands, soils, and the top layer contains earthworms. Next, these are the, in second table, we can see the physico-chemical parameters value. And these photographs, this is used to quantify the E. coli test. Just to test the E. coli, the E. coli is present in wastewater, and just after treatment, there is no E. coli presence in the treated water. After that treated water, I have accomplished the 3 experiments. First experiment is the growth impact of VermiAqua on rice crop. First, I selected one rice variety seeds and inoculation of seeds into the farm soils, and then I used VermiAqua in farm of Oryza sativa. And these are some results. The plant height was increased by 26.77% during the entire period of study. And the seed count was also increased by 110.72%. And the seed weight was accordingly increased by 109.12%. As well as the width of shoot growth was also increased by approximately 200 or 250%. So through photographs, you can also see the difference between the Oryza sativa or the rice crop. This is the control in the same field or in the same farm, in the same agricultural farm. I done this both the experiment. Next, I experimented on the onion, performance of VermiAqua on onion. Allium cepa root was concentrated at different concentration of VermiAqua. First, I put the onion bulbs at different concentration of VermiAqua, just to see the result, what happens at different concentration of VermiAqua. Through the photographs, you can see that at some concentration of sewage water, there is no root germination. This is a very simple but questioning observation. But at all concentration of VermiAqua, you can see the root germination. But at the sewage water, at some concentration, there is no root germination. This shows when I observed under microscope, when I observed this under microscope, I just came to know about some chromosomal aberrations, and there is some chromosomal mutations. At Vermi-Aqua also, we can see some chromosomal abnormalities, but these chromosomal abnormalities, according to the botanist, these were the very simple mutation which can be easily visible. But at the sewage, at the different concentration of sewage, we can see tremendous mutation or chromosomal mutation in the root or the chromosomal of onion. At my third experiment, I filtered arsenic contaminated water through vermifiltration unit. And I was surprised that vermifiltration unit is also able to filter the arsenic. I used high toxic arsenic concentration water like 10,000 microgram per liter and the 20,000 microgram per liter. And after filtration, 10,000 microgram per liter arsenic concentration. After first filtration, it reports only 7.716 microgram per liter. As we can also observe in the earthworm's body tissue. Earthworm's body tissue also observes that arsenic from the wastewater. That proves that earthworm's body bioaccumulates or absorbs arsenic from the arsenic contaminated water. So these are my some conclusions. Like vermifiltration units are sludge free, noise free, and the no electricity requiring system of operation. But one question is that we need to understand the genetic mechanism of earthworm. Which gene of earthworm is doing all the function for environment? We all know that earthworm is converting waste into wealth. But we need to understand and we need to just isolate that gene which is responsible for detoxification. And as a student of biotechnologist, I am always worried about that I hope there is no much more research on the genes of the earthworms. We need to focus more on the genes of the earthworms and which genes are actually responsible for this detoxification. Thank you so much. Keep avoiding clean water and use recycled water. Thank you so much. And if anyone has any question, and I want to thank Dr. Sudipti. She has a wonderful research on antibiotic resistance. I was thinking to do this antibiotic resistance test for the vermi-filtered water. But when I came to know from the Sudipti, then I am happy that you have shown me a very good result. And I will definitely see your paper and I want to see your paper. So how you have concluded this very good research. So I am thankful, David. I am so much. Thank you so much just to give me an opportunity. And if there is any question.
Thank you very much indeed, Dr. Kumar. Thank you particularly for sticking with your time allocation so closely. That's ideal. Much appreciated. Thank you. There were a number of questions through the presentations, which we will come back to in the panel, but relating to bioaccumulation. So you mentioned the detoxification, the accumulation of arsenic in particular. Do you think there's a point at which the vermifilter might fail because of the accumulation of toxic elements, or are there some mechanisms for detoxification we don't really understand yet?
Yes. One thing I must want to say that we need to focus on the genetic makeup or genetic mechanism of behind this detoxification methods. And your first question is, this is very good question, and number of times people ask this. So at any time, is there any possible opportunity that vermifiltration mechanism becomes finished or become accomplished or become blast high toxic level? Is it possible the vermifiltration could not work? So I will say, after some cycle of the purification, we must change the vermifiltration, what I say, the total particles we must change of the vermifiltration after 3 to 4 cycle.
No problem. Thank you. I'm sure we'll for certain come back to that question and questions of mass balances, the fates of particular compounds during the panel discussion. But thank you again for your presentation, Dr. Kumar. Thank you for your time. We are now going to take just a short 5-minute break before we come back to our final presentation and then the panel's discussion. So thank you very much indeed for all our presenters in this previous session.
Thank you.
Thank you. Welcome back to this final session of today's conference. It gives me great pleasure to introduce and hand the floor to Dr. Patil, who will give us our final presentation, and then we will go into our panel discussion to consider some of the questions that have come throughout today, and also some of those bigger questions about the potential for vermifiltration and how we make sure that that potential is fulfilled. So Dr. Patil, welcome. The floor is yours. Unfortunately, so we can't hear you.
We can't hear you, Dr. Patil. Can you test your microphone, Dr. Patil? We can't hear you.
Should just be an issue in the audio settings, perhaps.
Hello, sir.
Hello, sir.
Welcome. We can now hear you clearly.
Okay. So just a minute, give me time. So
no
I
problem.
can. Okay. Just a minute. Okay. Good evening, all. So I am the professor in Department of Civil Engineering, RIT Rajaramnagar. I completed graduation from RIT Rajaramnagar, Sangli, Maharashtra, and post-graduation from Walchand College of Engineering, Sangli, in the field environmental engineering. And in 2018, I completed PhD in civil engineering from Shivaji University, Kolhapur. And my area of the research is grey water treatment and performance evaluation of grey water treatment, low cost grey water treatment. So this is the introduction of my topic. So in introduction, water is the elixir of life. Without water, man cannot live. Without food, he can live for certain days. So as per the World Health Organization, we required 5 liter water for drinking purpose. So this is the per capita water availability in India. So in 1951, it is 5177 meter cube per year, and it is decreasing with time. Now in 2025, it will be 1341, and in 2050, it will be 1140 meter cube, means it is decreasing with time. For that, we have to search some sustainable solution for the development of society and for the development of nation. So these are the pictures of the water shortage. So in Maharashtra and India, many cities facing problem of water shortage. So we have to solve this water shortage problem by using recycle and reuse of wastewater. So what are the solutions? What is the solution? So we have 3 solutions with us. One is rainwater harvesting. Second one is watershed management. And third one is recycle and reuse of the wastewater. So in India or in Maharashtra, rainwater harvesting is already gained momentum through government agencies and NGOs. And they are doing a lot of work in the rainwater harvesting, so and watershed management. So example of the government organization, GSDA and other organizations. So they are doing the work for the sustainable development. So recycle and reuse of wastewater is not popular in India. So for that purpose, first we have to recycle wastewater. So what is the wastewater? There are 2 types of wastewater generated from society. One is grey water and second one is black water. What is grey water? Grey water is a wastewater generated from bathroom and cloth washing activity, and it is most reliable, less concentrated, easily available. So this is the characteristics of grey water. So I studied the characteristics, and according to that, I designed sewage treatment plant or small wastewater treatment plant for my campus, that is RIT Rajamnagar. So this is the current treatment options or current practices of grey water management in India. So disposal in the it is generally disposed in the municipal sewerage system, or it is partially treated and disposed into soak pit. That is for the further use. And sometimes raw water is used for gardening purpose. There is need to develop appropriate technology or treatment solution for the grey water. So what is the treatment technology? So we have sand gravel filter, anaerobic filter, constructed wetland, moving bed bioreactor, Vermifiltration, carbon filter, etc. So this is the object of my study. So I developed the integrated on-site grey water treatment system for RIT campus. So I will not focus on, because the agenda of today's conference is to discuss the use of vermifiltration in a wastewater treatment. So I developed this pilot scale treatment facility in RIT campus. So this is a pilot scale treatment facility that I developed in RIT. As a civil engineer, I studied a lot about the waste management and waste treatment, and according to some concept from waste treatment and waste management, I developed this treatment facility with the help of my guide, Dr. G.R. Munuli. He is the professor in Walchand College of Engineering, Sangli. So under his guidance, I developed this facility for RIT campus. And I studied this facility for 10 years, that is 2009 to 2020. So this is the modified integrated on-site waste treatment facility. So in that, I not use Vermifilter. So this is the beautiful treatment systems designed for the treatment of grey water. So it consists 4 components, that is settling tank, upflow downflow filter, horizontal flow constructed wetland, vertical flow charcoal filter, and treated water tank. And this treatment facility treats the grey water generated from campus, grey water generated from in educational institute. So this is the first part of my research. And second part, I used Vermifilter for the treatment of grey water. So this is the part second presentation, use of Vermifilter for grey water treatment or grey water treatment by Vermifiltration technology. So this is a literature review. So I used literature of the different researchers, and what they suggested to use Acin fetida for the grey water treatment. So many scientists, many researchers suggested Acin fetida is very effective in the waste treatment. So by this literature review, I selected Acin fetida for grey water treatment and laterite soil for the grey water treatment. So this is the gap in the research. So literature review shows that the studies conducted by vermifiltration for tropical climate region like India are very few, and visited vermifilter was not assessed for its suitability to treat the grey water. Canna indica vegetation is not used for the grey water treatment. So by using this, I developed the innovative vermifilter for grey water treatment. So this is a experimental setup used for the grey water treatment, and this is the photograph of actual vermifilter setup for grey water treatment. This is the plan for the grey water treatment. What it consists? It consists equalization tank, sand filter, or the second is filter, that is upflow sand filter, and that consists the natural material, and third is laterite soil visited filter and laterite soil visited vermifilter. Yes, I compared the laterite soil filter with laterite soil visited vermifilter. So this is the photographic view of experimental setup used for the treatment of grey water. What is the results? So for this study, I used diluted grey water for the diluted grey water as a feed for the vermifilter. Why I use diluted grey water? Because area of this filter is less. So I designed this filter system for 150 liter per day. And according to guidelines, I designed this system. So these are the results. So this is the result about pH, acidity, alkalinity, chloride. So this process approximately removes 70% BOD from the sewage, and vermifilter removes more than 80% BOD from the sewage. So this is the characteristics of the grey water. So this is the characteristics of diluted grey water. This is the characteristics of upflow sand gravel filter treated grey water, laterite soil visited vermifilter, and laterite soil visited vermifilter and laterite soil vermifilter. So this is the results. This is the results about the grey water characteristics. BOD to COD value is 0.66 to 0.7. It means this wastewater is easily biodegradable. So with the help of biological treatment, we can treat this wastewater. So I use this vermifilter for the treatment of grey water. So this is the results for pre-treatment, or this is results for sand gravel filter. Sand gravel filter removes 55% turbidity from water. BOD removes the sand gravel filter removes BOD 21%, and vermifilter, sand gravel filter, this removes pathogens by 42%. So pre-treatment efficiency for turbidity removal is 55%, BOD removal is 21%, and pathogen removal is 42%. And this is shown with the help of graphs. Then this is a result and discussion for visited vermifilter and laterite soil visited filter. So LVS means laterite soil visited filter and laterite soil visited vermifilter. And this is for HRT 2 days. So this graph is for HRT 2 days. Second graph is for HRT 3 days. Third graph is HRT 2 and HRT 3 days. So this is the result. So BOD removal. So laterite soil vermifilter found to be laterite soil visited filter found to be 50 to 60% efficient for the removal of BOD from the sewage. And laterite soil visited vermifilter is efficiency is 80%. Means laterite soil visited vermifilter is 20% more efficient than laterite soil visited filter. So the total BOD removal in laterite soil visited vermifilter 20% more than laterite soil visited filter. So BOD removal in the laterite soil visited vermifilter is maximum for 140 kg 140 kg BOD 5 per hectare, and it is for 3 days HRT, or it is for 3 days hydraulic retention time. So this is the guidelines. With the help of this guideline, we can design big sewage treatment plant by using vermifiltration technology. So this research shows the use of vermifiltration technology is suitable for the grey water treatment. So this is the result about the removal of TKN from the grey water. So TKN removal from laterite soil visited filter is 40% and laterite soil visited vermifilter is 54%. TKN removal in the laterite soil visited vermifilter is 14% higher than laterite soil visited filter. This vermifilter or laterite soil visited vermifilter is 14% more efficient than laterite soil visited filter. So this is the result about TKN removal from the grey water treatment. Then phosphorus removal. So I studied the phosphorus removal from the grey water. So for that I used UV, that is a spectrophotometer, and with the help of spectrophotometer I measure the phosphorus removal from grey water as well, means from the grey water. So average removal means what I find, average removal of phosphorus in the laterite soil filter is 36%, and average removal of laterite soil visited vermifilter is 48%. So what it shows? It shows laterite soil visited vermifilter removes 12% more phosphorus from grey water. Means this is the result about the phosphorus, and this is the total results. So for 1 year I studied the this system, and this is the outcome of my research. So average removal observed during the study period for the turbidity removal. So HGF means primary treatment, LSF means laterite soil vermifilter, and LSVFF means laterite soil visited vermifilter, and this is the overall efficiency. So turbidity removal, vermifilter or worms plays very important role, or in the BOD removal also worm plays very important role. So this is the turbidity removal. So as per the table information, so turbidity removal is 20% more than laterite soil filter. BOD removal is 20% more than laterite soil filter, and TKN removal is also 10% more than laterite soil filter, and phosphorus removal is 15% more than laterite soil filter. So these are the conclusions. So this is conclusion from literature. So literature review shows that laterite as a medium in a vermifilter with and without vegetation is not used for the grey water treatment. So this is a conclusion from literature. That's why I use this for the treatment of grey water. So what is the outcomes from my research? These are the outcome about the visited filter. So laterite soil visited vermifilter is found to be 20% more effective than laterite soil visited filter for the grey water treatment. So what it shows? It shows the vermifilter plays very in the grey water. So laterite is good soil. This is available in Maharashtra. So we can use that soil for the grey water treatment. And variation in the OLR and HLR affect the performance of the system. So that study I conducted, and as a result is suitable for 145 kg BOD5 per hectare per day, and retention time is 3 days. So for this hydraulic load and for this organic load, system gives better results. System gives better performance. Further, laterite soil visited vermifilter also reduce TK and P to significant extent. And visited vermifilter is found to be useful for the treatment of grey water at the household level. So this research is useful for the social development. So this is the outcome of my research. And at the end, what I suggest, so this treatment is very suitable for the social use, and vermifilter worms play a very important role in the grey water treatment. These are my few publications. Last slide, I thank you. So just a minute. So thank you. If you have any question, you can ask question. So thank you, sir. Thank you, David, sir, for giving me opportunity, and thank you for excellent coordination and organization of this conference. So this is my effort. So I'm teacher. I'm a civil engineer. Actually, I'm environmental engineer. I want to do some work for the society and some work for the social use. So I developed small treatment facility for the rural development, or that is for Swachh Bharat Abhiyan. So thank you, sir. Thank you.
You're very welcome. Thank you very much indeed for your presentation, and thank you also for respecting the timing. That is greatly appreciated. I've just one question. Did you have an opportunity to explore the mechanisms where you saw increased BOD removal in the vegetated filter versus the non-vegetated filter? Do you have any ideas about that?
So in vegetated vermifilter, worms plays very important role. So worm means worms is a friend for the farmer. So this is the saying in India. So they are making media porous, and in porous media, oxygen level is more because that plant supplies oxygen for the grey water treatment. So that gives more efficiency for the removal of BOD from the sewage or from the grey water.
Thank you. And we had a question in the chat box about the use of charcoal. And the question was around the absorption sites on the charcoal becoming saturated quickly and therefore needing to be changed, which might make the system a bit expensive. Do you have any comments on that?
That is on first system. So actually I use local charcoal, and with the help of labor, I clean the charcoal filter after 2 or 3 months. So that system becomes very efficiently. So because mechanical system is not required, only we have to clean with water, and you have to soak with solar energy or natural energy, and then you use, because that is reactivated. Then we can use that for the treatment of sewage. So I want to work with your team also in future. Thank you, sir.
Thank you. Thank you for those answers, and thank you again for your contribution. So we'll move now to the panel discussion.
Yes, sir. Yes, sir.
Thank you. So if I could welcome Chandrasekhar, Ajit, Tatjana, and Sudipti up to the virtual stage. And we will consider some of the bigger questions that have been posed throughout today's conference. But before we start with questions and answers, Chandrasekhar, would you like to introduce yourself to our delegates and say a little bit about your company?
Hi, David. Thanks for inviting me, and thank you, Rohini, for that. So I sent Vision Healthcare, and Vision Healthcare has been is basically incubated from IIT Bombay, and we are promoting technology developed by Professor Shankar, which is essentially a soil filter, vertical filter, which uses Paraffina type earthworms.
Sorry, Chandrasekhar, can you go a bit closer to your microphone? The sound is very low.
Hello? Is it better now?
Yeah.
Little, yeah.
Okay. Maybe it's the computer. So we have been doing vermifiltration for the last, I mean, the company was formed in 2005, but the first plants had been set up in 1993 by Professor Shankar's group. And since then, you know, a lot of researchers happened in how to reduce the space, how to reduce, improve systems in terms of performance and so on. And I'm happy to say that, you know, like all the others in this august audience, there is increasing understanding and appreciation for vermifiltration as a solution for decentralized wastewater recycling. And that we are seeing a lot of traction in the last couple of years now. And there's about our own company has done approximately 145 mld of wastewater treatment plants are being installed currently, and many of them are these larger municipal plants. And so, as Ajit has mentioned, you know, it's quite difficult. I mean, it has been quite a process to develop the credentials to get to a point where we are an accepted technology for such municipal plants. So we are now doing, you know, 50,000 person equivalent plants, 65,000 person equivalent plants, and things like that. And I mean, you have to actually demonstrate it in the municipal sector, show the credentials, and that's something which has worked out quite well for us. And I think there's still a lot of resistance because many of the government procurement systems do not immediately allow you, because they already have a technology in mind. So when you go out there and try to say that we can do this, but if the specifications are already with a mechanical technology, then none of us succeed. And that's something which we would like to work with every other, what I call as nature-based technology providers, to actually come and try to break this kind of tender specifications, which are not outcome oriented. It's more like technology. It's like a BOQ orientation. And many of these plants, after they are set up, you know, after a couple of years, you go and visit them, they don't work, and that's been a big concern. So that's just a background for the meeting, and we'll take other questions ahead. Yes.
Perfect. Thank you very much indeed for that introduction, and welcome to yourself, and welcome back to our other panelists from today. The first question I'd like to raise does come to this point of resistance in the market. So there were, throughout the presentations, there was this strand of the quite remarkable, I'll call them detoxifying characteristics of earthworms. And as a soil scientist, I understand some of that, but I could also see from a customer point of view, there may be some resistance to these kind of almost magical properties that we're claiming for the ability of the earthworms. And I just wonder if the panel members have any ideas for how to overcome the resistance to this kind of thinking. Do we have enough data to demonstrate the detoxifying potential, and is that data really robust to convince potential customers? And perhaps if I could pose that question first to you, Ajit, based on your market experience, what are your feelings on the kind of magic potential of earthworms?
Yeah, I mean, my thought would be that if you're trying to sort of establish yourself in the market and trying to promote, it's probably not a good idea to promise too much. So yeah, I think I would go with the fact that we can actually achieve what needs to be achieved far more efficiently. That's the line I think that we need to take and harp on. I'm sure Chandrasekhar can add to this. He has much more experience in trying to establish the technology. But already there are, I mean, when you are actually approaching the clients, it's all about comparing the space you need and the operation maintenance you need and the outlet parameters that you can actually achieve. So yeah, it's about trying to establish that you can get to what needs to be got to at a much more efficient cost and space sort of requirement.
Thank you. Sudipti, I wonder if you might like to answer the same question in terms of the evidence to support the power, the detoxification potential of earthworms.
Basically, regarding this question, I would like to answer about this specific properties of earthworms, that they have a very good antibacterial properties. So because if we talk about the coelomic fluid of the earthworm that they release when they come in these stressful conditions. So because when we put them into the vermifilter, we can say that they are kind of in a stress, positive stress maybe. So they release coelomic fluid. And in my lab also, we detected, we took this coelomic fluid and then we try to find out the detoxifying properties in terms of pathogens. So antibacterial properties, by doing some antibacterial assays, we did that, and we were able to find that their coelomic fluid contains those properties by which they are able to remove the toxic content from the wastewater. So they have that kind of properties by which they will, not allow other pathogens to survive, will kill them, inhibit the growth of other pathogens. And that's a competition between host and pathogens, probably, if we talk about scientifically. So that's their own mechanism to detoxify the pathogens from the wastewater. My area is more of pathogens and not of heavy metals or other parameters as of now. So I am more concerned about environmental pathogens. And one more thing is, uh, this earthworms share a very good relationship with microorganisms. So when they compete for the with the microorganisms, so there is always a competition for food, for survival, and in that the beneficial microorganism will win, and they will help us, in removal, and the pathogens and the bad microflora will die off. So that's the holistic chemistry or microbiology, we can say, that takes place in removal of toxins.
Thank you. Thank you. There was a great comment in the chat box around the presentation of these kind of systems, and I will interpret it as to be not over promising. So starting with the basic treatment characteristics, suspended solids, BOD, COD removal, and these are exactly the kind of characteristics we'd expect to be specified in a centralized wastewater treatment plant. And the things like the toxins, the emerging contaminants, those may not be priorities for clients. At least they aren't generally for in our market for municipal wastewater. I'm not sure how these further properties are driving the market in India, or whether really the focus should be on these primary characteristics of wastewater and the removal of those. I don't know if any of our panelists would like to comment on that. The focus being on TSS, BOD, COD, and let's come to the other characteristics later on.
Yeah, I would agree actually. So the COD and the BOD and TSS, if you are able to COD, BOD, TSS, total nitrogen, total phosphorus, maybe, if you can manage to get them down to whatever is being asked for by the authorities, that's sufficient for now. I think we'll probably, it is my understanding and it's my observation that vermifilters actually outperform conventional technologies, at least the biological part of it, in the removal of all these parameters, in reduction of all these parameters. And therefore, there is a large market here. Yes.
Great. Thank you. Ajit, from your commercial experience, would you like to comment on that?
I would like to add.
Okay, sorry, Tatjana, I'll come to you first.
Yeah, I think one aspect which would be important in this picture would be, as nature-based solution evolve out of a more sustainability as area, horizon, we target often at more sustainable practices. And there we come into an area, and of course, geographies where we do have water scarcity, where we do have land degradation. And when we reuse wastewater, we just strive also the aspects where bioremediation and of course also pathogen loss become more important. And there we can also see that in the research community, these questions are raised very often. So I think, of course, as of now, as to standards, we put a higher focus towards organic loads or the common standard parameters, but certainly if we do consider reuse practices, these kind of topics will come into play.
Thank you. Yes, Ajit, please. So you're on mute.
Sorry, yeah. So I just wanted to add few points to this. I mean, since we call ourselves nature-based systems, one of the things that we need to probably sharpen a bit more is the predictability of the whole thing. So I think the way many of these mechanized systems can actually put, say, 2 + 2 4, with you add one more blower and you provide so much more oxygen, and then you can actually get this thing down to, you can size the clarifier, you can do proper engineering design of all these aspects. Whereas I think there are still some, although we've come a long way in terms of arriving at these numbers, but that work needs to go into that and make the systems more predictable. If that can happen, we can really make inroads into the market as such. And I would like others to comment on this as well.
Please, Mr. Chalbra, please.
So I would like to give the commercial side on our experience, right? So as you know, it's a new technology. Even globally, what I understand, it's a very new and upcoming technology, and so it is for India. And in India, people are very cost sensitive, when it comes to effluent treatment, at least when the decentralized space, right? And they also looking at simplicity, like this package STP, what we have evolved to is nothing but a market-driven requirement. Right. So just to give you a small example, we've been commercializing this technology since 2010. So from 2000 to 2018, in 8 years, we could install only 40 plants. And in the last 2 years, we've installed more than 100 plants. So of course, the acceptability of the technology is also going high, so and so that the chief minister is choosing to inaugurate the plants. So it's a very, very small project for the chief minister to inaugurate, but still he's choosing to, because that shows the potential. And when such high level people are believing in the technology, right, then of course the acceptability and other things also come in. For the industrial effluent, what we started the practice is that we tell the customer, you know what, we will do the treatability at our end, share the results with you. You are more than welcome to come and see it. After that, we will bring a pilot plant at your site. We will do the treatability of live effluent, which is tested in your lab. Once you're satisfied, only when we'll talk about commercial and engineering, right? So that's really given a very good boost to our industrial effluent side. And of course, pioneer in any industry, takes the brunt. And that's why, Chandrasekhar and Ajit and ourselves, we've been struggling, and I'm sure the story is similar. We are paving the way for the future acceptance of these technologies, right? So yeah, that's my bit submission.
I'd like to add to Rahul's. We have met, Rahul and I. We have met multiple times in multiple fora in commercial negotiations and things like that. And I would like to say that at least in the government system, as soon as you say we have a patent, a lot of times people say we don't want the patented technology. That is actually a negative to a large extent. And in fact, the inventor who invents something, if they patent it and then they say it's a patented technology, obviously not too many people will have it. Going to market becomes extremely tough, at least in India. There is no real and easy way by which an innovator gets credit. I mean, you will actually start losing markets because they will say, okay, it's not in CPHO, it's not in your textbooks, it's not anywhere. I don't believe you. That's a standard kind of answers, questions that they will say, I don't believe you. What happens if it fails? I have to come to you only. Okay. And if I have to come to you only, there's it's not competitive and things like that. And, conversations stop around that. So we had to work very hard, I think 10, 15 years to get to a point where it is a certain degree of acceptance is there, which we know how we have managed to get, but it should have been easier.
Yeah, certainly based on today's presentations, it should have been easy, seeing the performances that can be delivered with the system. There's a comment in the chat box around UK utilities and my business, AquaEnviro, being interested only in very technical solutions. And I just wanted to respond to that challenge by saying that the INNOQUA project has a UK utility as a partner. So Scottish Water have installed a Lumberjack and a Daphne filter and are very interested in the potential for the technology in rural parts of Scotland, so northern Britain. So for sure, there is certainly interest in the utility community outside India and in the UK particularly. And we are technology agnostic. If it performs and it performs consistently, which is a point that that Ajit very nicely raised, then the utility customers are certainly interested. And the point on consistent treatment nicely lines up a slightly technical question from me, which is how important is the filter medium itself in these systems? Is the performance of the worms the priority, or is the filter medium, retention time, and other design parameters, are they equally important? I know that's a very big question, but I wondered if one of the panel members would like to take that up and give their response. Otherwise, I'll nominate somebody. Ajit, would you like to go first? Apologies for picking on you. How important is the filter medium itself and retention times and other design characteristics?
Well, with Chandrasekhar and others around, I should not be the first person talking about this, but I will still take a shot. So yeah, I think, yeah, quite important. Filter medium, I mean, because it's all integrated finally. The earthworms live in the biomedia as well as the filter media. So I think it's quite critical. Although some of the experiments that we had done when we were working with toilets was that the subsurface media actually didn't make a huge impact on the effluent quality. But there may have been different reasons for that. But what we found is that there's also one thing that I'm working on right now is the whole HRT thing. So one of the trials that we had set up, we found recently that there was a problem with even like nitrification happening. Normally, nitrification happens pretty well in all these filters. So we found that the HRT is probably too low and it needs to spend more time. So we are working on that. So I don't know how much studies are available. I didn't find much on the HRT aspect of it. Media, I think, as long as it's fairly well drained, that should be good to go, and where worms can actually survive and find places to sort of rest. There's also observations we've had with the arrangement of the whole biomedia. If you can make available places for earthworms to actually rest and recuperate, that helps a lot, because apparently they lay eggs where they don't feed. So that's been my sort of observation, not so scientifically proved, but I think that makes a difference. So, yeah.
Thank you very much. Sidipti, would you like to have a go at that question also? What is the importance of the filter bed itself, do you think, and the different types of filter media?
Yes, definitely. Filter bed is very important. It's equally important as the amount of food that we are feeding, the number of earthworms that we are adding, that's the stocking density. Other than these two important parameters, filter bed is basically the habitat for the earthworms. So we know that earthworms are the key driver of our process. We are quite grateful to the earthworms. So for them to perform efficiently, we need to give them the suitable bedding conditions so that they can survive, they can thrive upon, and they can do their work efficiently. So it's equally important. And other than that, other parameters that are to be taken care, as Mr. Rajiv just mentioned, that it should not clog, the filter media should not be clogged. So we have to make sure that it is porous, because earthworms will, they will do their burrowing activity, they will go deep down also. So it need to be porous, it need to be maintained, it should not be clogged, and it should be also able to survive the environmental conditions of your country and where you are living. That's also important, the temperature, because if it is some material that gets warmed up very easily, so earthworms may not be able to survive, because they're very sensitive towards temperature, pH, moisture. So everything is interlinked. The whole design that we also studied, we know that it's interlinked. So we have to take care of every small specific details when we are working with the live earthworm species. So that it is very important, definitely.
Thank you. Tatjana, I wonder if you have any observations from your Lumberfilter on the earthworm behaviors in the different layers, or whether that wasn't an aspect of the project that was researched in any detail.
this was not an aspect at the demonstration site itself, but of course, maybe to a certain extent in the pilots. So I don't see a remarkable difference in the different filling materials which we have used throughout the different demonstration sites. So here in India, of course, we had coconut chips as a filling material and gravel instead of pozzolana. But in the overall performances, I think the ranges which we achieved throughout the demonstration sites are rather in the same performance efficiencies.
Thank you. So if I could summarize, across the INNOQUA, the fleet of Lumberfilters, the performance has been consistently good for the Lumberfilters. Would that be fair? Yeah, okay, thank you. Next, I'll go, please, Chandrasekhar.
With that, that specific question, actually, all the speakers today, I think, had worked on the redworm. Hello? The redworm,
thank you.
Sinha fetida type lumbrifilters. And there, I believe that you need to have the cocoa chips or the wood chips, carbonaceous media as the bedding, which is working on more deep beds. We are looking at 3-meter deep beds and things like that. And many of these we had done in the 1990s and early 2000s. We had done an extensive series of studies between different kinds of soil-like media. I'm not talking about. So our lumbrifilters are soil-based and not quite the cocoa peat based. And there were definite and massive differences between the different kinds of media. Okay, so we found sand doesn't work, river gravel doesn't work, at least for the technology that we developed. Okay, so we found that there are very specific, soil type medias which have a certain biogeochemistry to it, because we had to have a certain adsorption to the media which would absorb the COD. So the first, as I think Rahul and many others have pointed out, it is an absorption and adsorption process on the media first, and then only it is grazed upon by the biology. And it was very important for us to actually design that biology well. In fact, most of the reductions in size that we have gotten now is because of better understanding of the media itself. So we're working at about 1.5 square meters per KLD back in the early 2000s. Today we are working at about 0.6, so almost 2.5 times reduction in space.
Thank you. That very neatly raises my next question, which is around the configuration of the systems. And some of the examples we saw today was, I'll call them single pass filters, and some were multi-pass, and some were vegetated also. As a panel, do you think there are significant differences between the single pass system and the multi-pass system, or do they both have advantages and disadvantages? Please, sir.
Yeah, so in our experience, also to add on to the previous question you raised about the design, right? So, so in our case, the whole evolution of the technology has been with a group of technical people. So people from biotechnology, biology, chemistry, mechanics, all put together. And every small element, like Chandrasekhar also mentioned, mainly it's about adsorption, right? So for adsorption, it's very important, the media you use and the function of earthworms and the microbial culture, right? So in terms of the quality of media, the porosity of the media, the size of the media, the specific dosing of making the earthworms hybrid and the selection of the breed and the culture mix, so everything put together. And not only that, even the pre-treatment and the post-treatment, right? So there'll be some compost that'll come out. How do you capture that? How do you make sure that the inorganics don't reach the bed? So whole design is very, very important. And also in our experience, the success of our current day achievement, that is from 600 liters where we started per square meter to 6,000 liters per square meter, is more to do with the number of layers, right? The typical size of the layer, the configuration of the layer, all that put together is what has caused us. And also in our industrial effluent, we also do multiple passes, maybe 3 pass or 4 pass or 2 pass, depending on the organic load. and how much efficiency can be achieved. So yeah, so all that put together is what is the final design basis.
Thank you. Do we have any other takers for the question on design and configuration in terms of sequential, parallel? If not, then go ahead, sir.
In general, I mean, what we found is in a single pass, we are able to get very good nitrification in many of our older designs. And for the specific government requirement of denitrification, we had to go with a two-pass system. When I say a two-pass system, it's not like take one and take it to the other. It's actually a mixing of ammonia and nitrate, which then gives you a denitrifying mixture, which seems to work better for at least our technology. It may not be applicable for others. So we were able to do denitrification in two pass rather than single pass. Single pass, we are able to do it, but you have to do a lot of recycle, which is energy consuming.
Sure, thank you. There's one, I wonder whether this tailorability, so the ability to manipulate the media, manipulate the worm populations, the retention times, this flexibility is perhaps also a market barrier. So it could be perceived the technology needs to be bespoke to a client solution. So that's a benefit on the one hand, but on the other, it may be giving rise to some skepticism because of its very versatility. Do you think that's fair? And if so, do you have any ideas to share about how we might overcome such perceptions?
What we mentioned is absolutely right.
So you're very faint, Chandrasekhar.
This is the design. Sorry, when you said absolutely, this is a big challenge because the design from different providers is very different in terms of sizing of all the equipment, and therefore it's difficult for a customer to be able to say, okay, this is the right design. That is a challenge. Yeah. And there is no such thing as a right design. All of it, I mean, it basically comes down to whether you trust that entity to.
Yeah.
Ajit, yeah, I think yeah, it brings back to the point I raised earlier in terms of predictability and consistency. So if we can actually evolve to a point where we can have clear set of guidelines where the sizing and all those, the worm density and the thickness of the filter media and different types. So I think this will evolve over a period of time where we'll have more sort of firm guidelines to follow, like you would have for a activated sludge process, for example. So yeah, I think it will take time, some more time and some more work in the field and some more brains to be put into this to get to that point.
Thank you. We're just coming into the final few minutes of this discussion now, and I will leave you with an opportunity to make some final remarks. So either a key message you'd like the audience to take away, or a key plea for something that you'd like, an action you'd like the audience to do. And I won't do that now. I will just ask a kind of an intermediary question to give you some time to think about that. And there was a nice comment again in the chat box around seeing is believing. And that's exactly the same in our markets. There is skepticism until you see it on your wastewater or in your country or under your climatic conditions. So before we come to this final question about take-home messages or requests of the audience, a question for you, Tatjana, around the INNOQUA solution. Can you share any information about the next steps for INNOQUA? Are there plans, for example, to commercialize the Lumberfilter, or are we still looking for additional research or additional partnerships to take it forward?
And say all together in general. So we are a research project where we have tested the system now over more than a year. And of course, we would require further insights, and it would be good to scale the system in terms of bringing it out in life, performing in many different households or decentralized systems over a long term. So in order to assess the operation and maintenance over several years, what does it mean in order to assess the costs over many years? So what it actually requires for INNOQUA. And yeah, for this, of course, it would be good to network, to collaborate, and to take all this further, to have the chance to form a ground for vermifiltration, definitely.
Great, thank you for that comment. Mentioning networking, I'm hoping Rahini will put the link to the Zoom meeting in the chat box, so that after this session closes, we can move into just a general Zoom meeting and continue the conversation amongst a wider group of us. So I will now come back to this pointer. What take-home message or what request of the audience might you have as a final statement from today's events? And if I could start first with Sudipti, what would be your request of the audience or your final comment to the audience?
So for all our lovely audience who have been listening, a lot of insights have been discussed about this very beautiful technology. But of course, every technology has its own limitations, and these nature-based solutions, which have just, which are novel, which are innovative, they also come up with their certain set of challenges. And we as a, key role players are constantly making efforts to improve upon these limitations, scientifically updating our knowledge, and through the continuous R&D, we are trying to explore more possibilities with this technology and how it can actually help the society and come up as a sustainable solution. So that's the key message from my side for the audience and for everybody. And thank you so much for all these very insightful discussions. Even I learned a lot about a lot of new things today, and it was really a great conference. Thank you so much.
Thank you very much indeed. So, Mr. Chabra, what would be your final take-home message or request of the audience?
Yeah, so one of the problems like all of us in the industry face is people's trust on the technology, right? So it's a new technology, the acceptance is low. And I know that at least Chandrasekhar and team and Ajit and team and us have been working really hard to crack in and beat the competition. And we are very open in terms of collaboration, in terms of inviting people to come and experience the technology. And like you rightly said, seeing is believing, and that's the mantra for the next few years till this technology becomes widely acceptable. And according to me, we are not a completely commercial organization, but more of a socio-economic organization, right? As far as the focus goes. And we feel that this technology is the future for especially a country like India. And so that we've recently, an Italian company has approached us to take this technology to Italy, right? So it's not just India, we're getting the traction from across the world. We have current discussions going on in UAE, in South America, and of course, Southeast Asia. So, we can see a bright future. Of course, it'll take time, but yes, patience is the key. And if Mandar, our technology head, would also like to add, I'll just pass the camera to him.
Hello. Yeah, can you hear me?
Yes.
Yeah. So my takeaway of the today's conference is that rightly started with Mr. Ganapathy, and he was very specific regarding the compliance, which is obligatory, particularly in a country like India. And as you know that the centralized and the decentralized systems are not same as you think in terms of giving the treatment efficiency. So there has to be very specific guidelines for the decentralized wastewater treatment plants also. And a technology like Vermifilter can do wonders for the country like India, only with the reason that the basic economy of India is the agriculture. And for agriculture, you require good amount of irrigation, which is required. Now in India, there are places where there is shortage of water, and the farmers are not able to take the crops which they want to have it. So if we can On one hand, we can solve the problem of sanitation in rural India, so that the wastewater which is just untreated and disposed of into the rivers and getting polluted can be treated through a technology like Vermifilter, and at the end product what you get is a very nutritive water with lot of nutrients, and these nutrients are actually needed for the soil for its maintaining the fertility. So if we have a holistic approach of this technology, then there are a number of advantages and the bionutritional byproducts which this technology can offer for a country like India. And that is how we should take this further, and we can further also research as to how this treated water is good for agriculture. Thank you.
Perfect. Thank you. I'll come to you next, Tatjana, if I may. What would be your take-home message for the audience, or your request of the audience?
I would like to know the feedback of the audience. But yeah, so being a researcher in this project, I feel very lucky and happy to be part of it and to have gained all the insights, which were for me very, very interesting to see that nature-based solutions themselves can have such excellent performance results. And I don't know who of the attendees had to, or got to know the Lumberifiltration or Vermifiltration as such, but yeah, under the current conditions, it's a little bit tricky to invite everybody to our site. We have a demonstration site, and I would love to present it directly to everybody and to see actually how the system works and how beautiful nature-based solutions can be. But at a bigger picture, if you look at the transition of wastewater sector, we have to look into so many changes which come along the different levels in a societal system. So right now, I think we're still in the niche. And as already mentioned before, if we have the bigger picture to follow sustainability with water reuse and also nutrients reuse, with the rising pressures, we have to change so much. And this includes also regulations where we enable actually nutrients recycling and water reuse. It requires approaches to transform. And what we see right now is that, of course, with, let's say, Western ways, which are still very popular and partially also have a very big lobby, that standards tend to develop into more conventional limits, and this we have to overcome. So I would wish that, of course, the audience had a good time today and got some interesting insights into vermifiltration and may take it further to disseminate and, of course, maybe take up research further or promote these systems. Thank you.
Thank you, Tatjana. I'm going to come next to Ajit, then Chandrasekhar, and then I'm actually going to give PG. I'm going to give you the final word. Although you're not on our panel, I can see you there. So if you don't mind, I'll come to you last just to share your thoughts. So Ajit.
Yeah, I think my take-home message to myself and everyone, I think, is the fact that this is a technology which has got great potential. So whoever is attending, if you're sitting on the fence, if you are lurking in the background, come on board. There is a lot of work to be done on this, and there is a lot of potential. All the rest of the technologies, whatever the mechanized ones we call, they are 100-year-old technologies. This is something new that has far more potential. So we need to together develop it and get it into mainstream. So let's all get at the job.
Thank you. Chandrasekhar.
So I will echo Ajit's words, and I would invite anybody who is interested. I have no doubt that lumbrifilters and vermifilters are superior to conventional technologies. It is only that the conventional technologies are mechanical, and they have a lot of the parts are available. A lot of vendors already exist, and the big issue is there is no standards of quality being asked for, at least in the Indian market where many of these technologies have been developed. When we go and compete in the market, I'm competing with a conventional technology provider who can give a solution at maybe even half the cost, because he knows he doesn't have to perform. Many of them don't perform at all. It's just like a signature. It's like it's a solution. It's a signature solution. It's not an actual technical solution. And since there is no certifying or even compliance authority that actually enforces these standards, it's a race to the bottom. So if one takeaway I would like to put in is that if CDD or others can come together and say, yes, we would be monitoring not just natural and nature based technologies, but every other technology and certified, actually a certifying body an ability to shut down people who don't perform is one big requirement. The government is not doing it.
Thank you very much indeed for those clear comments. I'm going to take away the expression signature solution and use it myself in my day-to-day work. So thank you very much indeed for that. And the final words to you, PG. What would be your take-home message or request of the audience from today?
More than a message, I think enough has been said, David. I will just express a few thoughts, let's say, not as a request to the audience, but I mean, firstly, I think very glad that this conference has reasonably established that vermifiltration is an idea, is definitely gaining ground, and it was perhaps the first one of this kind that's been organized in India. And I think all those who've been in the audience listening to it would reasonably be pleasantly surprised by the amount of work that various people are doing. And I think there was not enough knowledge of that. So after listening to it, it's pretty evident that there is enough applied knowledge as well as enough theoretical research that's going on. So I think it's great to know that it's gaining momentum. However, I mean, just as a message to ourselves rather than just to the audience, I would say it's pretty important that we keep 3 or 4 things in mind as we go forward. One is, I think we have to definitely pay a lot of attention to the robustness of the technology, which is how it could operate under, how can we make it more predictable? First of all, like what Ajit said, how can it operate with very little regular interference of fine-tuning and setting right system? And that requires us, I think, for us to be very honest about the drawbacks of the system. We all in our passion tend to overrate sometimes, right? And I think I'm just saying this, I know we need passionate people evangelizing something, but sometimes in our own evangelization, we tend to suppress the weaknesses of something. And that sort of suppresses it in our own mind, which we should not let that happen. I think we have to be very honest about what is not working, what is wrong with it, and why it's not working. And the more and more we say it, there's opportunity for that conversation. If we don't even say it, that conversation will never happen. So I think we have to be honest about the treatment efficiency that we are actually achieving, the consistency with which we are achieving, what are the other side effects and problems we are facing, stuff like that. I think when in conferences like this, we should talk about both the plus and minus, right? And then besides robustness, I think we should have all nature-based solutions are going to definitely on an area requirement or on cost. They have to necessarily keep innovating and keep getting better. Again, very important that we're honest about both the area and cost and not claim things which may work in very small cases or may work in theory, but not in practice. And it's extremely important that we showcase more and more and more in practice in real world situations, which I'm very happy to see Chandrasekhar, Transchem, as well as Prime-Move and Tiger Biofilters doing. So it's good to see. I mean, they are very important because ultimately that's the real test. And and I'm glad to see that many of them are giving a lot of positive messages about how effective. And I honestly believe that if there is a great idea which is working well, the system will naturally pick it up. You don't have to worry about regulation. You don't have to worry about, let's say, resistance to it. It will happen. I feel good ideas won't face resistance. So it might be a short-term phenomenon. It might happen, but it will soon pick up. So that's it. I think we should all keep an open mind. I think your question on whether it's a media or the earthworm is an important question. And we should be honest about that also, as to whether it's the earthworm or the media and so on, and stuff like that. So we keep an open mind and continue to look at this, but it seems extremely promising. And I am looking forward to see how this sector grows in India. Thank you.
Perfect. Thank you for bringing us back down to earth with those very practical suggestions. Much appreciated. So I just have some closing remarks, which really are my thank yous to our speakers. So to begin with, to PG Ganapathy, to Dr. Costel Bumbac, to Tatjana, to Professor Rajiv Sinha, to Ajit, thank you indeed, to Mr. Rahul Chabra, thank you, to Dr. Sudipti Arora, to Dr. Chandrajit Kumar, to Dr. Patil, and to Dr. Chandrasekhar Shankar. Thank you very much indeed for your contributions today. They have been greatly appreciated. I hope our audience have appreciated them also. And not last, but by no means least, thank you very much indeed behind the scenes to our colleagues Rohini Pradeep at CDD Society in Bangalore for helping make this event come to life, and to Christoph, who has also been working very hard behind the scenes coordinating the event. So thank you also to you both. Please join us for informal discussions and networking now. And Christoph, if you'd like to share the link again, I look forward to seeing some of you in the Zoom room after this event. So thank you very much indeed, everybody.